Hey, everybody, and welcome. Today is the first day of the milestone presentations for Cohort 1. Huge shout out to everybody who's been a part of it so far. It's been an effort. Thanks to Nick for the emojis. But really, congrats to everybody who's been working on your projects and getting to this point and working towards the deadline. A lot of learnings along the way, but all of which can be taken forward and used for future cohorts. Yeah, so the structure that we're going to follow today is every project has a 30-minute slot. We ask that the demo or presentation aspect lasts no longer than 20 minutes. It can be faster than that if you want it to be. And then we reserve 10 minutes for questions. If there aren't questions, you can use that the rest of the time as you see fit, or we can just kind of move on. But for the most part, I would say like the 30-minute, we'll be kind of strict when it comes to the 30-minute time period, just so we have everybody gets enough time to present. So before we get into it, does anyone have any questions on the structure? I'll also share the schedule that we have here. Oh, nope, that's the wrong link. You probably won't have access to that, sorry. That's a Slack around the Discord question that I just posted around folding schemes in case anyone's interested. And anyone has any passion about folding schemes, I meant to share the schedule, which is right here. Okay, so we're gonna go Zen, and then Mario, and then after that we have Kobe, I am Dev, and then Nicholas. Sound good? And we can kind of, if others aren't able to join, we can kind of just allocate accordingly. Okay, with that, Zen, take us away, and good luck.
All right. Okay, presenting screen. All right. Welcome to my show. My project is zkHumans. My audience, this is my pre-frame that I remind myself. Audience is Electors. We're proving proof of completion of milestones. And the request is to show more than tell. It's easier for me to talk, so I'm going to really try to stick to that. My slide here is really just to kind of help me bring form to my presentation. The way I want to go about this is dig right into the live demo to show that it works, but spare the wait time of transactions that are a thing that will kill time. So I have a recording to kind of show aspects of the transaction concurrency and things that I skip the wait time. If I go fast because I talk fast and I end up with more question answer time, that would be great. So here we go. zkHumans. This is a zero-knowledge cryptobiometric, self-sovereign, decentralized identity, collective association, and access control platform. This is phase 1 of development. That's really like the kickoff and get started with identity, and I'm very excited with the results. It's alive. All right, here's the demo. This is deployed right now, currently. It's a zkApp. It's got a smart contract that's deployed on the Mina network. And let's see, what I can show is that your wallet key, your Mina wallet key, is essentially your operator key for creating and managing multiple identities. So when I connect my wallet to this zkApp, I will see the identities. I went ahead and created this identity here. And if I were to use a different wallet, this other one, we will see that it has these identities under its management. So what that does, it works similar to a wallet in that way, that your operator key, your wallet, is a deterministic seed for creating and managing these identities. When you go to create a new one, you get an identifier from that seed, just like an account, like you get a accounts made within your wallet, and here's your operator key. When you go to create it, the way it works is you sign it with your operator key. There's a Merkle tree behind the scenes here, and you're creating a Merkle tree for this identity, proving that your operator key is within it, and proving this identity does not yet exist within the smart contract. You prepare that, send that, and ta-da, then it does exist. And from there, you can manage the identifier. So this is what it looks like when an identity has been created and it has one authentication factor. Now, if you're familiar with 2FA, factors of authentication, you may have a password, you may have something you own, like a hardware unit or one-time code, etc. That's the same concept applied here. Then you can add another authentication factor. Many are planned. This is a protocol that's designed to evolve. The protocol right now, we're supporting password and proof of human through CryptoBiometrics provided by HumanNode. Password, rather simple. You type it in. The provider is yourself. You sign it with your operator key to prove ownership of this identity. Prepare the proof that proves that this identity is within the Merkle tree of the identity manager. Send it off, and we'll come over to here to see what that looks like. Ta-da! Here's one that has a password added. Now, the process of creating these is a bit slower. You have to wait for transactions time, but then using it would be fast. The idea is that you don't create them as often as you use them. So you go through the process to set them up, and then you're able to prove them in much faster time, even off-chain. So here's the password that has been added here as an authentication factor. And here's another one where I added proof of person through HumanNode. This proved that I was a unique living human, and it is now an authentication factor. So I can use my CryptoBiometric to prove ownership of this identity. And it is up to the context that is authorizing this identity for what it requires. It may just require a proof. It could be your operator key and that's it. It could require a password and your operator key. It could also require your CryptoBio authentication. Now, when you look at these, you can see details. This is how it's stored. And these are the events. These are the off-chain storage events that are related to these authentication factors. You can click these transactions to see the details in the Explorer. They each have one in that way. This console is pretty handy. It'll show. I started as a little development tool, but it was really useful to see all that it's doing. So it's quite informative. And this is really the gist of what it does. It's an identity management system. Now to show, I'm a little skewed on my time because I didn't start exactly 6. I may be blitzing through this.
You've got a bit of time. Yeah. Feel free to take a bit of time.
Yeah. So this is the gist. I'm really happy with the UI too. There's a lot behind the scenes. The UI is kind of the more fun part for me. Connecting it to the smart contract stuff. It's a little in between worlds. I could say that there's so much momentum on the development right now that it was like, all right, it's time to present what. Hold on, I have to destroy my Discord because it's annoying me. Okay, I'm not quite sure how to do that right now, but one moment, please. Okay. So it became time to present, so I had to kind of pack it up to a form that was presentable. So a lot of things are in development. Let's see. Speaking to my audience and showing, there was some significant additions. I'll say that. Like the milestones, I feel like were covered quite well, and the real significant not deviation, but I had to deal with off-chain storage, and I didn't plan for that as extensively in my proposal. My initial idea Here I'm talking more than showing, but I'll get to the data.
No, it's okay. By the way, yeah.
Okay.
It's totally
So
okay, yeah.
this is a big deal, actually, and this is for us to learn. And Mario spoke to it too, and it's figure out your data. Essentially, your identities are data. That's how critical it was. My initial idea was that just get it going, use what I knew, what stacks I was familiar with, and there's quite some amazing developments in Cohort 1 from off-chain storage. And I thought, hey, community's putting some significant resources in this direction. Let's catch it on the other side and see what they come out with that I could just plug in and use. Well, it didn't have legs to stand on, so I had to dig in and do that. And so a lot of time went into that. It was a big deal to solve that, and I'm very happy because it is the data structure of zkHumans. It covers the recursive nature of authentication factors within an identity that is within a zk collective, that is within a zk super collective, etc. So it really hit the essence of what the architecture was expressing, and I exported that into a general format. It's in between worlds. It'll get better, but it's a library that will be exported that others can use. And I'm really excited about that. I wake in the middle of the night thinking about what this thing can do. I call it zkKV. It's a zero knowledge key value store. And as you can see here, this storage key, that's its identifier within the storage. Let's look at the data. Here's some show and tell. So this is the data. These are your keys. This is the value. And what you see here is random numbers. Yay, that's all it is if you don't have access. And that's the beauty of the ZK part of it, is that these are all hashes. And if you have the secret input to that hash, in this case, the operator key, the secrets of that operator key, and you hash it to produce something, you can access it. Otherwise, you can't. And so it is public, yet secret. And it works very well. So you have a key, you have a value, and then additionally, there is metadata. This is public, and this is a way to, I call it protocol as well. It's a way, because in the UI, it doesn't manage state. It can connect to the Merkle tree data. But the smart contract is the only source of writing, and everything else is read only. And so this meta gives a way to bring state into the UI. It could be a number of things. It doesn't have to be that list. This is the way I'm doing it, because I want this to, one, scale to the size of humanity, and two, be very distributed and decentralized. And so this is what does that. But you can use the zkKV metadata to have a reference to another zkKV data store or a regular type of database reference for your user, whatever it may be. Very extensive in that way, and I want to catch up to describing all that it can do. So kind of following that, I want to show how this data works and how the transaction concurrency is facilitated. And so I have a video. I recorded a process from beginning to end, including waiting for transactions time, and it took me 30 minutes. That's like a whole episode of something, so that's just too long. But if there's any questions from anyone, including Electors, this is very comprehensive. I filled in the blanks of waiting time with information, so it may be long, but it's complete for what it is. So this is actually kind of cool to watch for me without waiting. This is how it might work in the future, right? We don't have to wait for all these compile times, and we got hardware that does these proofs built into our phones. So we're compiling the zkApp, sign it with our operator key, prepare the proof. Now this is pretty zippy. I worked on older hardware most of the time. I was like 11 years old. I've just been kicking it, but I'll tell you, Mina kicked its butt. I got an M1 sitting here I now have access to. It takes about 2 minutes to compile, 20 seconds to do the proofs, totally acceptable. So here we go. This is where I want to jump in and speak. Okay, so we sent that transaction, and it gets picked up by the network. Then over here, we have an indexer service on the left side, top left. This is a server-side process that is watching the blocks for events. And so when a new event happens, a new storage event essentially is what's happening. A new identity is created, new authentication factor or modification, whatever it may be. An event is broadcasted. Now, this works very similar to the Redux state, where you have actions that go through a central kind of a certain flow. That the smart contract is the settlement layer, and it is you have to prove that then turns into writes. Everything else reads. So this indexer is watching for blocks. It collects all the pending ones. So that transaction went. It sees, oh, ta-da, we've got some pending transactions. Now this is where the transaction concurrency comes in, because many can come in during this block window that will then translate to pending storage. And so the UI picks it up. It's now got it in the database, and it is marked as pending. And what it is waiting for is settlement. And that happens by the prover. The prover then takes all the transactions that happen within that block and condenses them into a single proof of state transition, Merkle tree state transition. It sends that method to the smart contract, which sends another event to the indexer, and then ta-da, it's settled. Now, as far as like, this is how it's done for this zkApp, because in order to modify or add to an identity, it needs to exist. For other implementers of the zkKV, you could start working on the pending data right away. That's one event, one block. You don't need to wait. You could even record it ahead of time if you felt confident doing that. There's flexibility. So there is a good amount of wait time involved right now in setting up identities. The idea was make it work, then make it better. But the transaction concurrency is there by these two mechanisms. So here you can see in the top left, the indexer then received this settlement event. All pending transactions are now settled. A cool feature of this is that it's time aware. This Merkle tree data is time aware. And I wanted to kind of hold on to that as a feature that may be useful, because you may be able to prove membership, for example, in the past, or potentially even on pending data. So I'm exploring that, and that relates to one of my milestones that in the wording of it was not totally completed. Maybe let me wrap this thought up and then I'll go into that. So I set out to do the ZK program, recursive proofs. Now, I didn't say explicitly that was what I was going to do. My milestone said I was going to R&D and figure out what to do, but I did implement the recursive proofs as well. I went there, I got it working. It's not where I stayed, though. I commented that out to disable it, and the reasons for that is that it was computationally expensive. It surprised me in that way. And on my older hardware, it was taking like 20 minutes to set up and run through a whole test case. So it just killed my flow in that way. And then it needed more server resources than I had budgeted for. But it is there in the right context. It is the fully decentralized realization, and it's ready to activate as needed. What I did alternatively was a slightly more centralized, but much faster way to just wrap those proofs up and commit them. And so that really helped my development flow, because I didn't have to compile another program on top of one of the smart contracts. So I covered a lot of bases on that, and I'm happy with the results right now. And there's multiple choices in that. Okay, so let's see what else I could speak to. Before I leave this video, let's see what else there is to cover. I added the bio authentication here. Here we can see me adding a password. Sorry if this is just joining, I'm skipping. And then I did the bio authentication. Okay, yeah, and it actually steps through how this works. This works really well, and a lot of this I did in Cohort 0, the initial human node to Mina bridge and ZK Oracle, and it's working fabulous. I'm really excited that it's held up. So I add this authentication, bio authorize. So this uses the ZK Oracle to basically sign this identifier as your payload. So I click here, I go off to that Oracle. Click this big button, and that will send you through the human node biometric authentication process. It's doing a face scan. I cut that from my show here, but then you accept it and you are redirected back to the zkHumans zkApp. And now you sign it with your operator key. That's what you need to do to prove ownership of this identity. You prepare the proof that you own this identity, that this bio authorization is valid, and that it is within the identity manager Merkle tree. And as these transactions go through, there's a big ta-da that you now will have a bio authentication means for that identifier. Now, one of the cool things about it, and kind of an altering or evolution of thought, is that biometrics aren't required. Like, I came in this really heavy hitting, it's in the title of Anonymous CryptoBiometrics. It's still every bit valid. However, the generalization is that your Mina wallet is the base denominator. That's the base requirement. You need it to send transactions to the zkApp anyways. So that's the operator key. That was a big part of R&D, is what is the key? Well, it's that. And the CryptoBiometrics are optional from there. To say that they were required would be like to say, hey, I invented a t-shirt, but it only comes in blue. So in this way, it's much more generally applicable as a decentralized identity system. Am I good on time? I'm like kind of zipping, am I? Or am I?
Sorry, I was on mute. Yeah, so I think we started about 5 minutes late, so we have about 10 minutes of your 30-minute slot.
Okay, I want to leave time for Q&A, so maybe I wrap this up.
Okay,
Cool?
yeah, go for it.
Okay. Let's see, where was I? The code, I mean, you can check the code. I don't know if I have time for that, but let's just look at some of that for sake of looking at it. It came out really well. Sometimes I look at it, I'm like, wow, that's not very much code, but man, I went around the world to write it. I got like 500 commits on my GitHub, and most of those are squashed. It's quite elegant as it's come out. Here's an identity. They're all units of store in this recursive zkKV. Let's see what else I wanted to speak to. As far as my milestones not completed, one was just an idea that I explored, didn't work out. The other was the idea of destroying identities. As you see, there's a button. I've got code for it, deleting the store, deleting authentication factors. It's in there. It's just disabled, and I want to do it differently than I said. And technically, you don't just delete stuff off a blockchain. You need to nullify it, et cetera, et cetera. So my third was this idea of logging in as your biometric identifier. And this explains that. Here's my artifact for that. This kicks into phase 2 using ZK collectives. This is an illustration of the zkKV, key value store of Merkle trees within Merkle trees. So this illustrates a way to use your CryptoBiometric identifier as the sole ownership ID attester using the zkKV. I'd love to talk about this. This is one of the most exciting things. It's a side chunk to what I'm doing, but it's really useful in a general purpose way. I didn't get a chance to look at the details of how the other off-chain storage solutions are implemented. I'm excited to look, but I originally innovated this along the way, and it beautifully matches what zkHumans is in this recursive Merkle map. So ta-da! I can keep talking if there's no questions, but let's do question and answer. How do I not present? All right, let me present my face. Okay. Ta-da!
Nice, well done. Does anyone have any questions for Zoom? Yes, Matej, please.
Hi. Do you have any demo or like an architectural chart of the workflow of the authentication factors and how they can be consumed, etc.?
Could you repeat the question? Different words, maybe? Are you asking for code?
So if you have any demos or architectural workflows or charts or anything like that, like from an engineering perspective on how this is built, plus how the authentication factors are consumed at the end.
Okay, my proposal is a great resource for that. The architecture, it's got diagrams and explanations. That's a good resource for how it is working with the Merkle trees, that my architecture did follow through. And then I can show in code what a consumer of this may look like. Here is a smart contract that, let's say this is a compatible identity system that is using this identifier. This is a really nice abstraction, so you don't have to think about how it works, that you take in an assertion of the proof of ownership of identity and an authentication factor. Oh, I'm actually not sharing my screen, sorry. I'm showing my face as I talk about it.
All good.
Let's see, that's this. Okay, so this is an example contract here that has a method requiring authentication. So it takes in the proof of identity ownership and an authentication factor. And it will then assert that, validate the proof. And if it passes, then you can do something with it. And you can have access to that unique identifier for use within your zkApp database or smart contract. In this case, it's just emitting an event that shows that it passed authentication. Secondly, here's one that requires specifically the BioAuth. Yes, question? Am I answering the question?
I just want to ask, so identity assertion is a proof, or?
Yes. Yeah, the identity assertion is a proof. I'll show you that. That is right here. And this will evolve into a library, and I could say this wasn't specifically part of my milestones. This comes into phase 2 of how to really use this, but it is there for how to use it. And then it will be very polished, documented fully on how to take this to the next levels. So the functionality is all there. Here's the identity assertion. It's a struct, and it takes in an identity, which is itself a struct. That's up here. It has an identifier or a commitment to its root Merkle tree and metadata. And so it takes in that identity, and it takes in 2 Merkle proofs. One, to prove that the authentication factor you're using is within that identity's Merkle tree. And the second one is proving that identity is within the identity manager's Merkle tree, that it's registered. And then these are helper functions to validate those proofs are true. So that's what we're seeing in this abstraction over here, is validating those proofs.
Okay, so these are not actual snarky proofs, these are Merkle proofs. Okay.
Yes, but they're using snarky.js Merkle map, and they're in snarky.js. But yeah, they're Merkle tree proofs. It's using Merkle maps primitive provided by snarky.js. Is that
Cool.
a sufficient answer?
Can I have one more question? So
Sure.
You pass in this struct, which has all of these witnesses, and then in the place where you consume it, in the smart contract, which uses this authentication factor, does that smart contract has any access to the root hash of the actual Merkle tree?
Yes. It can authenticate it this way. So it doesn't have to use this abstraction. It could take this identity assertion and do it. And with that, it computes the root of that Merkle hash. And so, yes, it can have access to it. That part is okay. As far as like, you cannot, I don't know. I don't need to, I could babble forever on that. And it turns into some other ideas of how I want to really consume this in a secure way.
I meant, like, can you please show me where you call out, like from the smart contract where you have been previously?
Let's see, call out from the smart contract previously. So
basically the place where you pass this struct.
yeah, okay, so right here, require authentication. It passes this struct, the identity assertion struct, and right here, assert identity ownership. It passes that assertion to this method that we were just looking at.
Okay, but where from do you get the Merkle tree root hash in this example identity
Oh.
consumer?
Okay, so this comes from the API, the off-chain storage has the data. The off-chain storage data manages the Merkle tree data. There's a library for that, ID utils. Here is an example where it is proving ownership of the identity through the operator key. So it gets the operator key through the wallet connected to the zkApp. It creates this authentication factor right here, calls it the op key. This is a struct, this authentication factor, and here's where it creates this identity assertion. So this is the witness of that, and it is pulling that data from this right here. The identity is ID utils get stored Merkle map right there. Ta-da! So it passes in the identifier for that ID, and from there it has the Merkle tree data to then create the proof.
Okay, so you don't store the root hash on chain?
Root hash is computed by what's in it. It is also stored because it is a key within the identity manager. So yes, it is on chain, but through the zkKV, there is only one root hash of the identity manager's Merkle tree that is stored in the smart contract. Everything else is implied or proved within it. So it's recursive. It's a proof of a proof. And so with that, it really spares your state in the smart contract. One root hash then manages all the other stores. You can have many, like many. So yes, it is stored on chain through one Merkle tree root, and everything else is contained within it.
Sure. I was just asking the contract that is consuming the authentication factor. Is that linked to the on-chain stored root hash in any way? Or how do you provide the root hash to the consumer?
So root hash to the consumer, it's computed through the Merkle witness. So you create the Merkle proof, and then within
Sure, but you have to compare it with something, right? And how? So the value that you compared it with.
Okay, ultimate. Yeah. So what you compare to? Sorry, I'm getting disjointed with my Windows here. Okay, the assertion. You ultimately compare it to. All right, this is a good explainer. Okay, so there's two Merkle tree roots. This one, root 0, is the proof of the authentication factor within the identity. That Merkle tree, ta-da, you get that root, and then you prove that root is within the identity manager's root. That's the main thing. So that's root 1 here, and then bam, you say that you make sure it equals the commitment management, which came from the state
that's what
of
I'm
your
asking.
smart
Where's
contract.
the commitment manager coming from?
It's in the smart contract recorded as a state variable. And so it verifies that. That's where it comes from. It's stored, and then the pending storage then transmute it through the transaction concurrency as it evolves. Then it updates that. And so it checks to confirm that it is valid in that moment. As the proof is
okay, so your consumer reads the commitment manager from where?
The state in the zkApp.
Okay, but which one? The consumer itself or a third-party contract?
And this is happening in the identity manager that's deployed, the zkHumans identity manager.
Okay, so you read the state of the third-party contract to access the root hash of the tree where all your authentications live.
Yeah, and it's abstracted in that example. It works. It's but you don't have to see all that. You can access it more directly if you want, but it's abstracted in that example.
You guys can see my presentation right now, right?
Yep, you're good.
Okay, great. So, so first, thank you for inviting me to present today for the AdMeta and Mina Cohort 1 result. And yeah, so my name is Han, and I'm also the team lead of AdMeta. And so I just want to first have like a short overview of AdMeta and what we are working on and how we integrate Mina and zkApps. So AdMeta is Web3 advertising platform. Our aim is to match advertisements to users without exposing users' private data, and the privacy data protection is currently implemented using Mina's zk SDK and also the zkApps. And also, and our basic workflow is advertisers pays to promote their products in our platform, and users are getting rewarded after completing some advertisements. And between these two steps, there's another step, which is ad matching. And we use zk proofs to allow users to provide some of their information, but not all of their information, to do the ad matching and without exposing any privacy. And we have like a score-based model, which to allow users to have allow advertisers to have like a general understanding of which user groups they need to target to do their advertisements. And users gain scores in various predefined categories like DeFi, DID, or GameFi, so those Web3 categories, and through daily internet browsing and the usage. For example, if I use Uniswap like 2 hours per day, and we will consider it as like, for example, 100 score for DeFi. So yeah, this is a very simple rule, but we plan to have more complicated rules to consider not only users' usage time, but also like the the times they open this website, and also the times they search certain keywords on Google or some other like DuckDuckGo. And also we want to combine some on-chain behaviors like some transactions. But currently, we use Mina mainly to follow and abstract users' browsing behaviors using like Chrome. And the score are used as experience levels for ad matching, and also scores instead of browsing histories are collected, so to ensure no privacy data are exposed. And here it's like a very general architecture about how we abstract user data. And we can see from the left side, the user private data will be kind of abstracted as zk proofs, and this will be validated on Mina chain. And also this data will be uploaded to our AdMeta smart contract. Here is kind of a misunderstanding. It's not a chain, but it's like a smart contract we deployed currently on the Ethereum testnet. And through the smart contract, we will do the ad matching with all this users tag and also advertisers tag, advertisers advertisement tag. For example, a advertiser is like a new DeFi project. They want to gain some users who has experiences of DeFi, so they can have like a filter for their advertisement to filter the target group with DeFi score more than 100, for example. So this is kind of a very simple example to show how we do the ad matching. And yeah, we have also some other functionalities for advertisers to do their to publish their ad, and also to we have also certain process to approve any different advertisements, because we need to allow only some legal advertisements published on our platform. And here are the milestones we promised for the cohort 1. So the first one is the browser extension. We call it zkIgnite. And it is like an extension to allow users to connect their Mina wallets and AdMeta wallets. So actually they need to connect 2 wallets, and also they need to, and we can just calculate scores using the SNARK.js and also generate proof for different levels. And this is already done and like this. So I think it's better to, maybe let me just go directly to the demonstration part, so it's easier for us to see how it works. And let me first find this. Yeah, so can see here, this is our AdMeta Chrome extension. And so the first time a user uses this extension, there is like a whitelist we provided to analyze users' browsing behavior. So only the websites existing in the whitelist are analyzed for our behaviors. So we won't analyze all websites you browsed every day, to just ensure that users will know what kind of data we do. So if user clicks agree, so there it will first jump onto our web app. So this is, we need to first connect wallet the first time. It will jump to this this page showing that you have to connect 2 wallets. One is MetaMask, because we have we need to have users' Ethereum account to do all this ad matching and also reward distributing. And I have already connected, so it's easier. Actually, it's get this wallet will I will get the wallet from MetaMask. And so first time you click, you have to interact with MetaMask a bit more, and also connect to Mina. And I also connected. It's using also this our Mina, this Aurora wallet. And now it is already connected, and we can see that currently, sorry, I think I need to first do the data sync. Yeah. Oh, this is not. No. So currently, you see that in my testing account, there are already some scores. For example, the DeFi score and also GameFi score, Metaverse score. So this kind of scores are stored on our smart contract. So it's on chain, and it's these are open and public. And let's take an example about DID score, because currently I don't have any DID score right now. It's 0. And we have different kinds of ad matching schemes. And one kind is to do it using by matching the keywords of Google search. For example, if I currently if I search DID as a keyword, it's nothing but showing the result of Google's DID result, right? But if I do something first, for example, I want to browse latency, because latency is one of our data source for DID. You see, first currently is all unsynced score are 0. And if I browse this websites for more than 10 seconds, actually 10 seconds is very short time, but it's only for the purpose of demonstrating. And now you can see the DID score has been increased to 50. And now if I come back to this web app. And first we do the sync data here, and we do the data sync here. The first sync data is to sync the data from the browser extension to our web app. And if I click the data sync here, the synced data here will be, you see first, it will first update to the synced data from our extension, and then it allows you to sign a transaction. This transaction will sync the newest, the latest score data to our smart contract. And then if we do confirm, it sends a transaction, and the DID score of my current user will be updated on the smart contract side. And what will be different? Then if we do the DID search on Google again, you will see that, yeah, you will see that we have already the dedicated advertisement matched for this user, and also we will push like this advertisements. It's a bad example because the advertisements is also from Latency. Actually, this is not a smart way to do advertisement, but it's only for demonstrating. So for example, if we imagine that there's another DID project who wants to promote their projects, so this can be like another on another project, or you can also buy some different searching keywords, like you can buy like a searching keyword of your competitors, for example, so that if users search your competitor's name, your advertisement will be jumped out. So it's like this, and if we click here, it will jump onto the the predefined task from Latency. And actually, we have another version to integrate our AdMeta SDK. So if, for example, if we finished filling all this form and click submit, then the SDK hook will be called. So we will be informed that this user has completed this advertisement task, and then later we will do the ad distribution. But it's actually not integrated in this version in Mina, but this has been done in another version without Mina. But that's basically how we do the data part using Mina and the zkApps. And yeah, so as you see that we have first collect users' data on users' local browser cache, because if the data collected here are not uploaded at all, but only the data abstracted as a DID score will be uploaded here, and also only when users do the data sync can be updated on the smart contract side. Yeah, that's basically our website and demonstration. And let me come back to my presentation. Yeah, this you can see these are the browser extension and our testnet. I just mentioned that we have this smart contract which works together with our browser extension and the web app, and also it has deployed on Sephora, the Ethereum testnet. And this is our web app. Yeah, it was just showed as well, and also documentation and tutorials. Yeah, basically that's it. And any questions?
Thank you so much, Han. That was incredible. It was great watching your demo. I want to see if anyone in the space has any questions that they want to put in the chat or unmute themselves and share. I'll give you a moment.
Sure. Hi there, Han. Thanks for the presentation. Quick question. Have you guys managed to also create a Firefox extension?
Oh yeah, that's something we haven't done. Sorry, we just did this Chrome extension currently.
Sure, that makes sense. And then from perspective of the Mina contract, were there any particular issue that you faced while developing? Have you utilized it in the extent that you've planned, or were there any changes from the initial kind of ideas that you had regarding the actual Mina contract?
So the main difficulties we faced during our developments is about the storage, because previously we thought we can store all this users' data on Mina chain, and then we use some cross-chain communication to fetch users' data from EVM side to Mina side, but actually we realized that it's not possible, because we don't really have that amount of storage for all users, because we could have like a lot of users later with consideration of the scalability. So that's why we just use the smart contract, I mean the EVM smart contract side, to store users' data instead of on Mina's side. Yeah.
Do you mean user data or user score?
User score. Yeah.
I see.
Yeah.
That does make sense. Yeah, sure. Thanks for answering that.
Thanks.
I have a small question. Maybe I missed it. But what's the current, in which phase you are currently? Do you plan, is it public, or is the website somewhere in the beta phase or something? Or
yeah, it is currently
what's your plan on that?
Yeah. It is currently public, but we don't have our extension published on the market, on the Chrome market, but we have to do it to compile and build it manually from our GitHub. So that's current thing. Yeah, so that's something we have to install our extension manually from the source. Yeah. But we have a guide, like a tutorial, to tell you how to do this from step to step.
Awesome, great work, by the way. I really
Thanks.
like the idea, and maybe one thought. It's based around trust, and if you what I saw right now, it's a very nice interface, but maybe you can also improve on it. And it would be very easy to do with some templates. For example, if I use all the time Envato, for example, they're very inexpensive help templates, or Tailwind have a lot of interesting templates, and you can very quickly improve your user experience by many times, you know.
Yeah, but, thanks.
But it looks very nice.
Thank you for the advice. We use Tailwind, I think, with our front-end developer, but we haven't used any templates, I believe.
Yeah, there's tailwindui.com. You can check it out.
Okay. Okay.
They're very nice and professional web templates, and you see it all over. The big companies all use these templates basically. It's very easy then to make like user login and all this normal stuff you need.
Yeah. Okay. I will bring this back to our front-end developer. I'm not professional with this, but I will take it. Thanks.
You're welcome.
Just one other small thought that just came to my mind is, are you currently using a testnet of Ethereum? But if you would ever go to kind of more production level with this project, would you consider like Ethereum mainnet or any L2s?
Yeah, that's a good question. Actually, we plan to first launch it on Polygon if we plan to do it on the mainnet, because we have talked with some other projects who are interested in our project, and some of them are on Polygon, and some of them are, for example, BSC. But there are not so many projects on the Ethereum mainnet because of the gas fee or something. Yeah, that's something we first want to do, is to do it on like a popular one, like a Polygon, for example.
Sure, that makes sense. That also gave me another thought when it comes to, you know, because you mentioned that you have a problem of storing the score of the users on Mina. You could potentially consider maybe deploying a contract for a user each, and that straight away gives you at least 8 field elements for a single user. So that potentially acts, when you're thinking about, you know, if you're mainnet, storing that on the Mina is actually cheaper, because that will require only 1 Mina transaction fee to create an account. But maybe that's something you can consider, to try to store the score for each user on separate smart contract that is coming from the main contract. Something to think of.
So you mean choose to deploy a Mina contract for each user?
Yeah, so if I want to register with AdMeta, I would, you know, deploy my own contract, and then at this point I already have 8 field storage element, which in theory you could store your score for each of the metrics you have.
Okay, that's something new, and we haven't considered. We will investigate into that. It sounds very interesting.
Sure. Again, great work. Thank you very much.
Thanks.
Thank you, Han.
Just to recap, this project that I'm presenting is called BioSNARKs. That is basically trying to bring zero knowledge proof for biotech to improve therapeutic development. The problem that we are tackling, that drug development prices has skyrocketed since the 70s, and despite all the technological advances in biotechnology, there are only 1 out of 10 new drug candidates are successful. And the successful here is an overstatement. Usually the improvements are tiny, like, for example, giving 1 or 2 months extra time for overall survivor in terms of cancer drug, for example. Other way to represent this problem is by Irum's lab, that shows that currently from $1 billion US, you are able to develop less than 1 successful drug, and while in the 60s, 70s, this value was around like 20. So something somewhere went really wrong how drugs and therapeutics are developed. And of course, like in last decades, this problem was really looked into it, and there have been like many studies explaining why this happened. And the number 1 reason is the siloing of research data. There are thousands of laboratories around the world that they have like negative and neutral unpublished data that would be like very useful for others to do modeling and computational studies or other kinds of experiments. There have been like really inefficient decentralization in biosciences, and also problem with the reproducibility. So many things are done very manually. That there is no ledger from experiments. Many things are like in lab notebooks, and small number of experiments are repeated. And this also like decrease trust in scientific reproducibility. Also, when you want to come up with a new drug, for example, from academia or a small biotech, when you approach big pharma companies or industry, these non-disclosure agreements and material transfer agreements are taking a lot of time, and you are always worried about the IP. So the solution that we wanted to bring in is that we could like boost this data exchange with zk. to prove work, optimization, prediction, and protocol in bioscience without revealing exact processes or IP-sensitive information. So I will be presenting our milestones, and I will briefly go through what were our initial milestones. And I will try to be as interactive as possible, but at the moment, I think this was heavily research and exploratory work, but now we really see the bits and pieces that we need to come out with a proof of concept. So our first milestone was to look into the use cases and the architecture feasibility. And we looked into wet lab and dry lab uses. So wet lab is the actual laboratory where you do the experiments and use hardware, and dry lab is the computational software, for example, where you do modeling, molecular docking, protein folding studies, and so on. So about this, we started to do a white paper, and I will also present some use cases and sanity checks and discussions in this presentation. Second milestone was to actually deliver a zkApp proof of concept for a computational experiment. And initially, our initial milestone was to do it for protein folding. However, we saw that it was like too complex and not necessarily the best use case. So after discussing with academic representatives and from the industry, molecular docking was like sort of like the number one highlighted use case, because new types of molecules are computationally developed in the range of thousands. So there is a lot of data that people want to dock and showcase that if they have like something promising or not. So for that, I will do what's the status of this, and we will show our scrappy GitHub and some presentation. Then milestone 3 was like to do a light paper and the website. So basically, currently there is not much of a light paper, but we have like a deck with all the use cases and also the white paper in use. And the milestones 4 was to engage with BioDAOs. So BioDAOs are bioscience DAOs in the decentralized science field that took up in the recent years. And there have been like few of these, like actually seeing very good success with pharma industry and also with very good universities. So we see that good academia ranging from King's College, Oxford, University of Copenhagen, Pfizer are moving into this side. So we also did interviews and discussed with developers from these DAOs and companies. So we had discussions with Molecule, LabDAO, which is like providing computational resources for scientists, WALI-DAO, which is a synthetic biology DAO, and they are developing like supporting science to develop new biomaterials. And also we had discussions with a small molecule company. Like the content of these discussions is some of these are like non-public or NDA, but we are happy to provide evidence or further information for the electors if they need. So I will be jumping bit within bits and pieces, white paper and this presentation. But first, I will go through what kind of use cases that we identified that zk is useful for bioscience. For example, when you have like an expensive experiment where you use the same hardware, for example, but you have like different biological interest, you have to generate proof that this was executed according to the protocol without revealing IP. Then again, opening up this negative and neutral data, we can generate proof for this data that they were done according to certain standards. Then we also looked into use cases if we can provide zero-knowledge NFTs. So this proof of work as an NFT just to replace non-disclosure agreements. So like an initial trading essence. and proof of optimization, molecular docking and binding for federated learning and machine learning approaches that sort of like had the largest feedback from industry and these BioDAOs, that proof of optimization is something that is the most heavily used in this like age of federated learning and age of computational bioscience. And many zk projects in bioscience and healthcare, they are looking into like to anonymize biobank data. So for, let's say that you could provide the study a genetic set of certain patients without revealing the personal patient information. As the starting problem for when we went through architecture sanity checks was how we are able to generate a physical representation of a physical or biological state of an experiment that is either state of the software or a hardware meaningfully, that we can snarkify, and what circuits we can use this. And that this was like a really a developer pain point. So we started this, that okay, we have a group of people who are like computational, like bioinformaticians, and actually familiar with cryptography as well. So we just have to get some snarky developers, but it was not that easy. So when we actually presented what we would like to build, then they went on to literature reading. We provided all the literature and help that we could, and then set up also with developers of certain tools that we wanted to snarkify the output. But this part was a sort of like pain point. So we ended up like, okay, how would be like a zkApp that could look like for this? So we wanted to go on to do a user interface for tools that they could do a simple statement as the proof that, okay, we have a drug that inhibits certain target, but we don't show the drug, but actually you show an immutable proof. And then as a pharma, acting as a verifier, they read in this proof. And the proof has to be like generated to something meaningful. So it should be like from this binding study or docking study, and the proof and the correct run or the validity would be stored on the blockchain. So what I wanted to show, yes. So this kind of use case for the molecular docking, we did a lot of reading into, okay, what are the bits and pieces that we need, and we identified a tool called DivDock, which is used a docking tool used by academia and also industry. That actually you run molecular docking experiments and you have certain output from this. But the output from this was like still like very complex, because it had this use machine learning to produce the docking prediction. And it was again like very heavy to look into the model, and developers were afraid. But then we realized that we are able to export the DivDock's model as ONNX, and ONNX is this standard model for neural models that is compatible with the tool zkL. And zkL is a tool set that is able to generate sort of simple statements in zk manner, so they can snarkify the statement that this private information, let's say my drug, was run through this public neuronal network, and it was correctly produce this output. So basically, we ended up defining what are the tool sets that we need. So basically, we will have a user interface that user can enter the diff-doc docking app. Then we can put the ONNX model to zkL, and zkL will generate the proof that we actually put on chain. And the proof will say that this was correctly run, and it will output this confidence score. So I will don't go into the mathematical details, but what people would look when you are like a pharma company and you are interested in the molecule of, like, for example, and the researcher is showing you, you want to see this like very good binding scores. So basically what we will do, that we will provide this proof with some public information, what is the confidence score for this molecule, and that it ran through the diff-doc correctly. And this is like how now I'm showing bits and pieces, but how it will look when we have like a separate user interface for like this BioSNARKs docking. So researcher will input a protein target. So that, let's say that's like a cancer target, and the ligand, and this is like the private, this is like the trade secret. So the ligand. And diff-doc is basically running predictions how well this drug is binding to this protein or target. So this will take some time. So it will generate like this diffusion model with different binding position, and so that's what the model is. The model is like very complex, looking at like atomic properties and molecular properties, and tries to find the best binding solution. And if this confidence score is within certain limits, that it means that it has like a high or low likelihood that it will bind this target. And of course, if we, for example, if it's a negative data, that it's not that good confidence, that's also very useful, because you can train other models that in a zero knowledge fashion, that you could do that. You can exclude some molecules from training data. So we also set up a roadmap, and for us to go back to the milestones, the important thing is to really have like a starting point where we can interact with industry and these decentralized science players to integrate zk into their biotech stacks. We started to write a white paper, so we go through the problem statement and observations about this problem and the possible solutions with use cases, architecture iteration. Then we describe why molecular docking is a good problem as for a proof of optimization solution, and what are the tools that are typically used and could be implemented for zk, why zk learning is zk machine learning for the drug discovery is important. Of course, in addition to the IP aspect, it also opens up possibilities to train a lot of things with negative data. So it can actually could have benefit to develop better therapies. Then people who have like better understanding of the proving system here, writing section about how we can make it more compatible, the circuits to Plonky methods and the kinship proof system. Then we have a section about implementation to Mina, and also long-term plans to actually have a framework that is like biotech tools that use machine learning, and they have a model that can be exported to this ONNX type. Then it would be like very easy to generate zkApps specific for that models. Then we started to look into what are the capabilities that are missing for Mina and SNARKy.js for correct implementation, and also what we started to work in for this DiffDoc. We also look into this experimental parameters from traditional docking tools and in the DiffDoc tool. So this is something that these are like physical or chemical properties of the molecules that we can hide or put public on the depending what is the request from or what is the need or the use case. And we started to put all these bits and pieces and the BioSNARK repo on GitHub. So actually the project name is probably go to Snarky Bio, because we would like to have this like larger big picture of providing zk for biotech. So BioSNARKs is like just the first implementation, and we just started to implement this ONNX input and importer. So it's in very early stages, the actual coding. We have a lot of pseudocode and some example data from test runs, but we also put all the architecture ideations for this. What we managed to get is to really have like a very good team that took us some time to actually get the people here that know they understand Snarky to the extent that we can code this. But also it took us time to get to this bits and pieces. And we also have like a good ecosystem with different universities and industry players where we believe that we can really test a lot. So hopefully this was just the starting point, and we could really have this first proper MVP within a few weeks, because now we really see the steps that are needed for it.
This I can only say like congratulations and bravo, because for a while I think you have been bringing lots of value, not only just in code or technical perspective, but I think the best businesses or startups born in this spirit, using these expertise, a very deep expertise in an area, and also creating the right team, finding the people from the ecosystem. So a big shout out to you, Patrick, for showing this work and bringing value. And yeah, let's see. Yeah, Nicholas, I see your comments. Do you want to chime in? Or
Yep.
Yes, sure. Yeah, so just going through the again, as I said, to call this impressive, I think it would be an understatement. I mean, I'm not. I know close to nothing of your field, but it sounds amazing. I just had two questions. I think I was very curious in understanding how do you deal with or mitigating healthcare regulations when it comes to the commercial adoption of your solution, and when it comes to biotech companies sharing this data. I was just wondering how do you not necessarily convince them, but the solution works, but I'm pretty sure it's a process to make them.
Yeah. So we looked into the level that we are providing this privacy bigness or preserving the data is a layer or level where you don't interfere with regulations. So this is like molecular discovery phase between companies, and they actually would be happy because they would be happy to use more data, and with that solution, they don't have to share their data. So they will share just like a piece of data. So it gets back to this like Wild West example of the Z case. So you can have a small bits of the puzzle that, okay, certain molecules that have this confidence score do not bind this and this. And this is very useful when you run thousands of experiments to train your data, because then you have better data. And there have been like EU consortia called, I can also show them, we are reaching out them as well. Just a moment, I put this here. So this consortia was all about this, that they used fragmented data for federated learning and optimizing processes, but they did not use zk per se. So here the zk has like additional security and also computational advantage. So, and they had like 4 big pharma partners in that. So when we have the proof of concept, then we will reach out. And also regarding milestones, we had this sort of like a start or launch of the SNARK Bio with website that would come probably latter half of August, because we would really like to showcase this proof of concept with the DivDoc tool. And the reason that we are using this or like fixated on this DivDoc tool, because this is like the sort of like the state-of-art tool that is used by academics and industry for molecular docking. And that when we have this first step, then we will try to get like a proper front end so people can use it very easily, and then get some academic groups using it.
Thank you very much, Patrick. Really looking forward to read the paper when it gets public, and the white paper, and for the proof of concept. Thank you. Thank you very much.
Thank you.
Perfect. Are there any other questions? Yeah, I see.
Just,
yeah, please.
Yeah, I'm just curious, and it's not so much related to the milestones, which I think you've done a great job on. I'm just curious in terms of potential next steps with funding. I know that you were in a few conversations, and what the appetite has been.
Yeah, so we really look forward to a seed funding for, especially for BioSNARKs, and what we are, we have pretty much had all like due diligence call and even contracts with the investors. So we are just like waiting for final steps from that. And the next step is to really get like commitments from the developers, and also with developers who are now having zkML oriented calls for Cohort 2. We are in very close touch, and they onboarded some of them. For example, thanks Yasin for the intro to Leak 1 and other devs as well. So even if they don't get funded, we still have funding from the Cohort 1. So I think we have been like very economic with the use. So we would be happy also to fund these projects. And also, I think that's like really probably there were some like that's like a very important use case generally, the zkML, and also for the developers from the EZKL are very familiar with the bottlenecks of Mina SNARKGS. So I think that kind of like patching and helping with the dev tools for that, and that have the infra to be able to do ML stuff on Mina, I think that's also a priority for us.
Okay, fantastic.
Well, good afternoon. In my case, it's afternoon here still. My name is Rafael Campos, and I'm going to present my project, Cryptographic Proof of NFT Endorsement, CPoNE for short. So first, I want to share with you something that happened a few weeks ago. My former teammate just quit. One day he sent me a message, and he just told me that he wasn't going to continue. So I went ahead and I asked my very good friend Tito Thompson to help me with the project. He's a full stack and Web3 developer, and he was in charge of all the front end part of the project, and he's gonna explain to you how the front end works in a few minutes. Oh, okay. So that we are all on the same page, these are the milestones that I originally committed to. We achieved all of them. Number two, though, we actually didn't have to do anything to achieve it, because the Neil Foundation's ZK Bridge already includes exactly what we were expecting to create ourselves. It's a smart contract on the Ethereum blockchain that verifies Mina proof on the Mina blockchain. So I included it as a achieved milestone, even though we didn't have to do anything. Okay, I hope that's okay. Here's the original proposed solution. These are exactly the words that I wrote in my proposal. I didn't change anything. So the language is a little bit unspecific, because by then I didn't know exactly how I was going to solve the problem. But basically, what I'm trying to do here is to be able to verify that someone, for example, in this case, I used Buzz Aldrin as an example, that he endorsed an NFT. In this case, it's an NFT commemorating the moon landing. Okay, so the flow is he tweets something. I mean, by then I didn't know exactly what, but he tweets. It turned out to be a hash. He tweets a hash. The Mina zkApp verifies that that hash is exactly the same hash as the NFT metadata. Then a proof is generated on the Mina side. That's bridged over to Ethereum, and then an NFT is minted. Okay, that's a very 10,000 feet explanation of the project. Now I'm going to explain exactly how we did it. So here we have the general architecture. These are the 7 steps that go into producing the proof on the Mina blockchain. In the next slide, I'm going to explain how we bridge that over to Ethereum. So the first step is to have the NFT metadata and compute a hash of the metadata. This hash is sent to the endorser. In our example, it will be Buzz Aldrin, okay, so that he can tweet that hash from his Twitter account. And at the same time, we deploy a contract, a zkApp on the Mina blockchain, okay? And this zkApp contains the hash of the NFT metadata, the hash of the endorser, and that's it. I mean, I'm sorry, I'm going to advance here because I have a more detailed explanation. So here is the hash, and these are the state variables that we use inside our zkApp. So we have the Oracle public key. By the way, we used the zk Oracle example on the Mina docs as inspiration for this application. Okay, so I'm doing exactly what the example does, which is validating that the data that is sent from the Oracle is signed by the public key that was originally committed to the contract. Okay, that's why we are storing the Oracle public key. And by the way, the Oracle is a separate repo. Right? I also shared it in the proof of completion. And it basically, what that Oracle does is it retrieves the tweet from Twitter using the Twitter API, and then it produces a JSON object that is exposed via an API for the zkApp to retrieve. Okay. So the other 3 state variables that I'm using are the NFT hash of the metadata, the endorser hash of the endorser's Twitter handle, and I also have a Boolean variable called isEndorse, which is originally set to false, and only after verification is set to true. Okay. So the next step is to have the prominent person tweet the endorsement. All they have to do is tweet the hash. I mean, any other text in the Twitter's text is ignored. We only look for the specific hash. Okay. Then that is retrieved by the Oracle from the Twitter API, and it generates this JSON object, which has the original endorser's handle, the text, and a signed object that includes the endorser's hash and the NFT hash, okay, and the signature, of course. So that's step number 5. Step number 6 is the actual verification. When the zkApp is invoked, I mean, the verify function or method in the zkApp is invoked, and it basically retrieves the original Oracle public key from the Mina blockchain, the NFT hash that was used to deploy the contract, the endorser's hash, and it just, it validates the signature, and then it compares the NFT hash retrieved from the Oracle with the NFT hash stored on chain, the endorser hash retrieved from the Oracle with the Oracle endorser hash on chain, and finally, if everything checks out, it sets the Boolean to true, the is-endorsed Boolean to true, and we by then, when the is-endorsed Boolean state variable is set to true, we can assume that the NFT is valid, is endorsed. Okay, so that's the end of the valid verification process inside the Mina blockchain. Okay, now I'm going to explain how we bridge that from Mina to Ethereum. So we already have a smart contract on the Mina blockchain with certain state that we want to verify on Ethereum. So for that, we are using Neil Foundation's proof market. I don't know how aware or how informed are you guys with the proof market from Neil Foundations, but basically the proof market is like a marketplace where people can request proofs, zero-knowledge proofs to be created, and other people can provide the service of creating those zero-knowledge proofs. So that's how it works, basically. So they have certain APIs that allow you to submit a request for a proof and then to retrieve the proof once it's generated. Okay. So we begin with the state of the Mina ledger and the state of the Mina account, where in this case our zkApp account, and we go ahead and we invoke the proof market's API to send the state of the Mina blockchain. Okay, we retrieve the Mina, the state of the Mina blockchain using GraphQL query, and we send that over to the proof market via an API. After a while, which we are not sure so far how long it's going to take to generate proofs. It can be a few minutes, it can be hours, or it can be days. We don't know, because this is a very the Neil Foundation's proof market is in beta still. So I think there are not actual provers working right now generating proofs. So we can only imagine how long this is going to take. But once the proof is ready, we can retrieve it from the proof market via an API and include that proof, which is just a JSON object, into the metadata of the NFT that it's going to be minted. Okay, so here in step 2, we invoke the proof market API, we retrieve the proofs, we include those proofs in the metadata for the NFT, and finally we mint it. Okay, so once the NFT is minted, the proofs are incorporated into that NFT. So when anyone needs to validate if those proofs are valid, they just have to retrieve them from the IPFS service and invoke the smart contract that Neil Foundation deployed on Ethereum to validate those proofs. And those, that Ethereum smart contract emits events that attest that the proofs are valid. So that's how it works. Okay, so that's the preliminary explanation of how this works. Now I'm gonna pass to Tito for him to run the demo. So the way we are going to do this is via a pre-recorded video, because of the that a lot of time that it takes to wait for the transactions to finalize. So he's gonna fast forward those parts of the video. Okay, so whenever you're ready, Tito.
I'm good. How you guys doing? Thank you for the warm welcome. Appreciate it. As Rafael already introduced, my name's Tito, and I will be demonstrating the front end. So let me present now. Just do the entire screen. By the way, you guys can hear me fine, right? Am I all good? Okay. Sweet. Okay. Hide. Oh, okay. Into the matrix. Okay, so let's go to here. So this is just a brief video. As you see here, though, we also do have it like just up running here. But for now, I'll just show this. All right, so this is just the right of the landing page, you could say, right at the front. And we're presented with a drop zone. And so I'll play the video. And from here, you're going to see on the left-hand side that same with the through a tutorial that you guys have done, you use a web worker to get it done. We incorporated that into the application as well to make it all sync. And so as you can see, we signed up to Berkeley and we proved the account existed by logging into the Aura wallet. And as well, I'm already signed in through MetaMask to Sequoia. And then from here, you just click the drop zone and you can upload an image. So here is an image of a diamond planet from Melody Sheep. I don't know if you guys know the YouTuber, makes amazing content. He's a great watch. But yeah, so then here you include the title, creator, description, the endorser Twitter handle, and the date. All of this is going to be included in the metadata that is uploaded to IPFS. And so obviously I can't get Melody Sheep to endorse this so soon, so I just had my burner account do this. And right when we could click submit for endorsement, we load the contract, and then we compile it. And so I'm gonna fast forward just through this bit real quick, right here. And then at the same time as well, we are deploying the contract, but then let me go here. We're deploying the contract, but then also setting the NFT hash and the endorser hash. And so all that, the NFT hash is just the address of, we use, in this case, we're using the Sequoia address, the title, author, description, image URL, like the encoded image, because as of now, it's not included in IPFS, not yet. And then the endorser, right? And then we just hash that using SHA-256, just so it stops doing that. We do this. There you go. Okay. Oh, did I just break it? Oh no, we're good. Sorry. Yeah, so that's what's included. And here, nice. And we get the pop-up. We have to approve it to be sent on chain. And here you're able to copy the hash. And this is the hash that the endorser is going to tweet out. So here, I just said again, as Rafa was describing before, it could be whatever, doesn't matter what's in the tweet as long as they have the hash. And then from there, you can just say taking that collection. And in a second, I'll show you on chain, but this is a demo of like all your NFTs that you've submitted for endorsement. And then as of now, here, I'll just show you on chain. Yep, this is the pending, but I'll go back real quick. Yeah, so this is just the simple layout for them. It shows the image, Yep, shows the image, the creator, description, endorser, all that, NFT hash. You go once again copy, and then here you're going to notice where it says non-endorsed, and then also check tweet. And so once it's actually deployed on chain, and so skip through, and then yeah, once it's actually deployed on chain, look at this, bam. Here, and also one thing to note too is that every NFT is its own Mina smart contract. So whenever you cycle through your NFTs, like in the collection, you actually have to reinitialize the ZK instance. I couldn't tell you 100% confidence that's the most optimal way, but is the way that it worked best for us. Since every contract is unique, we have to, well, because of the state variables, it's better to just load it, compile it, and initialize it every single time. And so that's what you'll notice on the console on the left. And so here I don't think I didn't skip that yet, did I? Okay, there you go. Now I put in tweet, check tweet. Perfect. Okay, and now it is creating the verify transaction. So I'll go to it over here just to show you. Which one is it? Yeah, here. And so when you click check tweet, we're actually calling to, I'm using just a simple Next.js backend, if you allow me to say backend, with Next.js, just with the API on the back. And what that's doing is fetching from the Oracle itself. And it's getting the Oracle NFT hash, Oracle endorsement hash, and the Oracle signature. Then we retrieve that. And then from there, we're creating the verified transaction. And so back here, that's exactly what it's doing. And so it takes a bit to prove the transaction. And then from here, once again, you have to sign it. And once it's deployed, and then see, I just cut it through, click endorse. Ideally, it would just automatically refresh, but due to like state variables, state management, I just have to hard refresh by going to the home screen and then back, meaning React state management. And then bam, so it's endorsed. And just to show you as well here, just to ultra verify, the first time you click it, it does show up immediately right here. So it's already endorsed. Right when you click it, it just basically calls a getter on it. And yeah, so let me go back here, endorse, nice. And then now, so I clicked on it, mint NFT. So it's minting the NFT right now. Well, exactly what it's doing, it's uploading, it's first posting the image to IPFS. So it's pinning it. And then from there, it then pins the entire metadata, including the title, description, endorser, the date as well, and the image URL to IPFS as well. And now let's get through, takes a little bit. Now you're asked to confirm, right, the transaction, and then bam. So now it's successfully filled. You can see right there, it has now been posted on Sequoia. We just have a very simple ERC 721 contract, CPoNE, that all users are just calling to mint. And then from there, so it's there, and then here's the IPFS metadata, right? And so you see the title, image URL, all that, as well as the proofs. So, like Rafa was describing before with Nil Foundation's like prover market, it's not fully up and running yet. So, but we are calling it. At this point, you can see this is actually the error message we're receiving for the ledger state and the account state. We just get no proof found status error. So we thought to include that because if it was up and running, ideally it'd be there. You would have the entire proof in the metadata of the NFT. And then from there also just show you it's on OpenSea because again, OpenSea can just retrieve all that. And yeah, so that's basically it for the front end flow. Of course, I know you guys have questions, but that's all I have for right now. Okay.
Thanks, Sito.
That's all.
Thanks, great presentation. So that's it, basically. That's our project. I don't know if you guys have any questions or comments.
Sure. Amazing. Thank you very much. Sorry, thanks very much for that. I'm so glad to see that kind of improve of your initial process. Thanks, Raphael, for explaining how you kind of initially thought and how well I think you actually designed at the end the flow of the project. I think that kind of showcase that you understand the whole flow and how it works. So that's very good to see. Also, the front end looks great. I think it's amazing. The functionality of it also, I can see in my eyes that it actually can be quite useful to actually have verified NFTs endorsed. So that's really actually great use case to see. So that's very interesting. I guess I'll go to my kind of standard question, which is during the project development time, have you guys encountered any particular problems with Mina that you guys had problems with? You kind of expected it to go smoother, or maybe you expected it to go actually harder and you found it easier? I guess we would love to hear that.
Yeah, well, I kind of I felt while working on this project that Mina is like a moving target. I mean, I sometimes was trying to run code that was written like 2 months ago, only 2 months ago, and it didn't. It didn't work because there was a newer snarky.js version or something changed. So that was my feeling. But I mean, that's okay, and that's expected, right? Because this is a very early stage project and it's moving very fast, and I mean that's awesome. But it's just difficult for us developers to, work. I don't know if Tito, if you have any other feedback.
Yeah, I'd say just like regarding like front end, I mean, it's definitely a new experience, like from a Web3 developer perspective. Like specifically like having to do a ZK instance for each different NFT, because like usually NFTs are, you could have 10,000, hundreds of thousands, right, in a single contract. But having each NFT per se be its own Mina smart contract was interesting, especially because it all runs in browser. And I'm coming from a perspective, in Austin, I was in a conference in Austin. I went to the Mina, they had to talk like a whole day event there. That was like the first time I learned about Mina, and I was like getting used to it. And I've never like played with something in browser. Like everything's in browser, which is really cool. But obviously there's some, like, I think Rafa described it well, it's a moving target. So overall, it was a good experience, to be honest. It was just a lot of like unknowns that I had to figure out, but I had no problem with that. That was fun.
Yeah, that seems you guys actually smashed it very well. So well done for that. I fully understand your pain. It's the case every month something changes, and you have to look at the comments. Like, oh, when was the comment? Was it older than 30 days? Then yeah, it's a different story. So yeah, oh, that's great to hear. Yeah, thank you very much, guys. Well done.
Thank you.
Yeah, I was going to say, I'm pretty impressed that you were able to figure out the nil prover market and actually build it into like directly into your application, because I was expecting much more kind of a explanation of this is how it would work and not actually like this is how it does work, even though there's still some hiccups. I think like to me that shows that you've kind of really gone above and beyond with it. And I also think like as potential other options emerge between Mina and Ethereum, which I'm hoping there are a few very soon that also this can be applicable there too, because I do agree that the use case is very much there. And especially for kind of like Web3 native, so like at the very beginning there, I feel like there's a lot of like viral potential with what you could do with this.
Okay, can you see my screen? Fine.
Yes.
Okay. Let me first just quickly go through the full presentation. So my project is a CTF capture the flag. The milestone here all are executed and achieved. Any other minor changes here? First, in the first line, I have 2 media game and 1 hard game, and finally I decided there are 1 media game and 2 hard game, because 1 game is more difficult than my expected. Okay. So here I will go through this in this PPT first. So for the milestones, I have this platform. So I have this like the scoreboard and challenges. So we have totally 5 challenges here: 2 beginner, 1 medium, and 2 expert for hard. And each challenge will have some details how to do, and they have some help info. They can find some useful resources there. So for the challenge, they will deploy, capture, and do some coding, and then finish the capture and done the challenge. That's the process. For the scoreboard is listed all the players who achieved the scores. Okay. During this implementation, I have some contributions I listed here. First, I have 2 PR has merged, and 2 issues is still open there, but not very urgent. And I have special thanks for I get help from our wallet. They are also Chinese, so I talked to him, made a lot of communication, and finally he added the feature of signing arbitrary message, which used in the account system. So others thanks to Jasim for coordination, and my 2 mentor, Carol, Gordon Freeman, and Gregor Mark for the answering my question in Discord, and Ms. Pardo for merging my PR in GitHub. That's my thanks. So here I record a video, but I want to show you the real world first. Try to share the real world first. Let me see here. I already put this site online here, minactf.xyz, and when you get here, you find two buttons. First, to start, you can connect your wallet. Sorry. And once you connect it, they will show what your status you are working on. So this is, I have a new account, just try the check-in. We can try the check-in first this time. So go to the details. This check-in I already have done. I can reset and try again. So go here. I can click deploy. First, they will require a signature to check to log in the account. And second, they will get in the transaction from the server, and I will have to send the message, send the transaction. Okay, still getting. Oh, still getting. Let's watch a video. Okay. So to the detail, and if we get the transaction, yeah, after signature, if we get the transaction, we can confirm the transaction and send to the Mina blockchain. Okay. After some time, it will be on chain. This should be long, so I accelerated the video. Yeah, I accelerated the video. That cost some time. You can take a look at time here. So finally, this transaction is on chain. Okay, so the user are allowed to download the project. So after the download the project, we can take a look. Let me take a look. Oh, still. Sometimes the network is not very good. Oh, still loading. Okay, let me show you the project I already downloaded here. This is the checking project. First, when you go here, you will read the README, and first time you will npm install to install the dependencies here already executed. And the second, in your .environment file, you set your environment key. Here will be empty for the first time. And last, you will execute the npm start to execute some code in the run. Here's the main code here. So here the code the player should to modify to what they want to. For the checking challenge, that was very simple. So they just execute this code, the npm start. It all will be all good to go. So they get the transaction, and they will show. Let me confirm. Oh, okay. So after a week, they will try to go on chain. So they maybe have some time. Here's the transaction. You can see it's pending, and maybe after some time. So let's take a look at the video first. Okay. So after we download the project, I already show you. Just use the npm install and set the private key, and start npm start to start the program and execute the zkApp.play, which is in the contract. And again, the process costs some time. And when the first this transaction sent to the blockchain, it will not still be in pending status. So when we back to here to check, we will get a flag not caught yet. So we have to wait. So I can open the transaction and watch its status changes. So here I also accelerated the video. You can take a look at this time here. Refreshing. And I remember when I recorded the video this time they cost almost 12 minutes to finish, I remember. Okay, so after this, the will can be complete and submit to the server. Server received the submit command and record the score, and your score will be recorded in the scoreboard. Okay, so that's the whole process. That's for the simple checking. And let's take a look here. Oh, it's included. So here is go to the second steps. So we can take a look at this project. So it's similar to what we already showing here. So different challenges have different challenges have different different challenges have different projects. Let me check. Every challenge you can download the project individually and open them to start coding. And let me show you something else. So after the coding, let me show what the challenges is included. The first challenge is the check-in, a very basic challenge that helps user to learn how Mina contract works. So that just follow the guide and establish the SNARKs development environment. Then it will go. It's simple. Just download the project and start the npm install. That's all set up. So the second challenge is prime. The target is player are required to find the two number greater than 2 that multiply to equal 19. So why this challenge is hard is not so easy as this is counterintuitive because 19 is a prime. Why two number can be multiplied to this number? So that's the point. But indeed, in the see the number is a field number. So two field number multiply, we can get the modulus, and then it can be 19. So if we want to get this number, the number would be showing like a very big number. The third challenge is verifier. Player are given the public key and requires the player to provide the signature corresponding to the public key. So with the player only have the public key that was written in the smart contract, but they are required to provide a signature. They don't have a private key. So why this is hard? The player must understand how public key generated and write a program to find the right private key. So the private key is vulnerable. It's easy to find. It's a small number, but they have to write a program to loop to find the number. Okay, the fourth challenge is maze. So we are using a single field number to represent a maze. The player needs to understand the maze and move to the exit. So for each step, player can move toward the 4 direction, one step, each step. Okay. Why is this hard? Because the representation of the maze is a single field number. So how to decompose the field number into the maze? That's the point. So, and the next hard point is how to send the transaction to the Mina network. Okay, this is amazing. The final one is the hardest one, and also is the interesting one. So we are playing like an RPG game. We will starting by level 1 mu. We call mu means the cat. So level 1 mu novices with countless templates finally become a full level mu heroes. So here we have rules. Each mu have 5 tributes and start by 1, 1, 1, 1, 1. Each time 2 mu can breed 1 new mu with a tribute randomly -1, 0, or +1. That means the second time they can be maybe just upgrade to 2, 2, 2, 2, 2. That's a lucky one. So we can repeat until find the full level mu hero. Why this is hard? This is theoretically infeasible to compute naively because there's so many possibilities. So we should program carefully and maybe have some heuristically search to find the feasible solution. Okay, and that's it. Let's take a look about the GitHub repository. We have the contracts and UI, and let's take a look about the contracts here. Take a look at source. We can have this 5 challenge here. Every challenge have a corresponding unit test. Let's take a look at the hardest one. We can take a look here for the level 5. We have these steps we have to, but here also I provided the program to search for the solution. here. Yeah, it's still heuristically search for the solution. Okay, it's not very easy one. So I think this can be a challenge for them. So for the contract here, maybe we can take a look. We have mu is a struct 25 attributes. And for the main contract, we have Legion. Legion, how we say the Legion? Legion is a group of mu. So every time 2 mu with a new mu will be added into the Legion, and next time we can have the two any one of the 2 mu to breed a new mu. So finally, we maybe have several mu's to some mules, and then the last mu can be the mu hero, which is full upgraded. Okay, so we have some program here. So for the attribute, we just take the seed and yeah, we combine the 2 mu into a new one, and each time we take the seed and combine its attribute. For the contributor, we just take a okay. I think yeah. Do you have questions or some focus that you want me to show?
Yeah, congratulations, Shuang, and please, Andreas. Yeah.
Yeah, I want also say it's really fun, and I was on the website and checked it out, and it's like encouraging, yeah, you know, like, and great work. I really enjoy it.
Thanks.
Yeah, this is Jerry. I'm from Branchy, and I'm leading you to zkDID, the project for the Mina Federation zkIgnite Cohort 1. So, wait a second. Anyway, and let's just direct leading. So, basically, zkDID, that stands for Zero Knowledge Decentralized Identifier. So, in our design, zkDID is a Web3 DID core compatible and data-centric DID protocol that enables users to take back their data rights. And with zkDID, users' data can be stored at anywhere with a hash, and users can truly own their data with a proof of signature to access it without compromising the flexibility of data control. And yet we do believe it could achieve a privacy to make the real privacy for users. Also now, zkDID are on the halfway, in my opinion. So what's done is a registry and resolution and attaching attitude, and also a route delegation. Why I quote the route is because this is pretty route, and there's a lot of stuff to be done, including some like full implementation of a delegation and documents, and a lot of other stuff. I'm not listing in here, but I may add it in the future. So the current is I have a lack of complex type support. That is, I found that Mina do not support a mapping at a time. So I can create a complex type for like solidity mapping, and so if you limited the case to use it, I hope maybe L2 will make it better, work for a better solution for it. And yeah, and delegation is I know it's pretty rare, and we will define it delegation type schema in the future, and also ownership verification. And that is, we are finding a way to verify users' ownership and prevent it malicious actions from other parties. That's basically we work for the signature, and other potential security issue may not discovered at the time. This is still in progress, and yeah, there may be more while debugging. So the next step, there will be a delegation schema that allows developer to define their own schema type. Like I say, I wanna dedicate my data to a third party that I trust, and the third party can processing my data, or they can access my data securely and privately. So we don't need to leak the data to others, and also attestation with trust party. And that is basically say you have a trust of third party, like a user owned public key that's addressed on Mina public chain, and you can sign proof or other type of data and make it attestation to you that to prove something that you need or he might to make for you. And also the signature verification, that is you can just sign your sign of a signature and give it to others. So you do not need to really own Mina to touch them. I mean the part and the rest part. Maybe a fee payer will pay the rest fee for you, and also other like testing, other stuff. And but I think the most important, yeah, let's just keep going. Yeah. So allow me some time to introduce Branchy. And here the left above is the Branchy logo. Branchy is a thematic AI privacy DID protocol designed to create a decentralized data advertising engine and establish a visual trust system. It's basically the project I'm working on, and zkDID will be introduced in the British ecosystem as core part of component. If you are interested in it, you can check out the last slide. There will be a link to the website. Okay, so basically that's the end, and I think I will see you in the next time.
Okay, and let me start. My English is not good, but I will try my best to make it clear. Okay, and at zkIgnite Cohort 1, my proposal is Anomix Network, and we have team are going to plan to carry out a zk-zkRollup layer 2 solution Mina. We wanna to protect the privacy and improve the scalability. And during the 3 months, we have completed the 5 milestones, and unfortunately in the standard milestone, and then the last one we didn't carry out because of several reasons. One is that our time arrangement. For example, at the first month we cover from COVID-19, and our team become ill become ill one by one, and this course of about 2 weeks, and then our layer 2 design has refactor for 2 times and spend the rest total time on the implementation of layer 2 protocol. Actually, we at the beginning, at the end of May, and we found our original design has a bug about double spending, and we try to improve and find solutions on refactor our design and improve our key components like Mokuchis and our circuit. And the second time, we also found some other issues. Then we make a double refactor again. And then about 1 month and a half, we spend the time to carry out the previous 5 milestones. So and why we cannot carry out the milestone 6? Because at the middle of June, our UI colleague suffered from illnesses, so he has to leave the team temporarily. So the rest work are carried out by 2 of us. One is me and the other one is Comdex. Yes, and we try our best to carry out the Jeff UI and also SDK during milestone 6. Yes. So during this meeting, I wanna present some about our code and our GitHub repo, and also our steady UI, that which you could directly know what Anomix, which is the Anomix official entry point, what it is looking like. Just wait a moment. I need to switch to my another. Oh, okay. It seems that I want to switch my browser, switch my screen sharing on my other browser. However, okay, there is some issue just now. Okay, and this is our repo, and we have carried out all the components except the OnoCache UI pages. So let me show you the component and our design. Please look at here. During our I wrote a documentation about how we decide Anomix, and yes, and these are all the markdown documentation that you could see how we write the circuit and how we decide the user journey. Okay, 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 and this is the component. If you could go to read it later. And let me share about the you could see in our GitHub repo, this component OnoCache UI is at milestone 6. I will show you the static pages to you later. And this is we are a layer 2. Firstly, you have to register your account and then deposit and then send and then transfer and then withdraw your fund into layer 1. And also we have some mechanism about SK window. When the network is broken, then user could quickly escape from layer 2. And we have carried out all this. These are our circuit. Yes, and we have contract and dry split, and this is our for depositing. This for send. This for send. This for send fund, transfer fund, and withdraw, and these are the inner lookup part. We have to batch all the layer 2 transactions. Is by this circuit. And these are the lookup part. After we look up all the layer 2 transaction, we have to sync. We have to make a then we got a layer 2 block, and then we have to finalize the block at layer 1. All the circuits are here. And actually, I just said we experienced the refactor of our design. This is the version 1. We found this is the version 1. You can see that at this order we will process all the layer 2 access and then make them in queue and make a block and broadcast it to the layer 1 Mina network. And we spend almost 1 month to refactor it, and we arriving at this version. It is we batch all the layer 2 transaction in a tree legacy in a tree-like legacy merging pattern. And this could improve the layer 2 performance. Yeah, and our circuit is about this. Yes. Okay. And this is the we carry out a Merkle tree, but with reference to other open source project, we refactor a Merkle tree with SNARKs to use it in our project. And this is the SDK for you to interact with our layer 2. And it is also embedded into OnoCache UI. Okay, these are all the key components and the documentation part. And at last, let me share with you our Jet UI, because we don't have enough time to combine the SDK and the UI. So what I could present now is about what our UI look like. Actually, this is not the final version, but we don't have time to improve it now. We have 2 entry points. One, as a new user, you could Is the time rest? Is the time enough for me? Hello?
Yeah, you have a couple more minutes.
Oh, okay. Oh,
I think you have one question from Haresh, who asks, does it only support payments?
Let me see the question.
It's
where it is?
in the chat, right part. Yeah.
Okay. Does it support payments? Yes. It supports deposit Mina into layer 2, and then you could transfer within layer 2 and also withdraw Mina to layer 1. But we have no time to integration to make them combine together and make an integration. So it is a pity that I cannot show you the whole flow. And actually, we have tested all the circuit, but some of the circuit cost much time, so the time is limited too. And we think that we later could maybe could record a video. Okay, let me go on. Yeah, two entry point. One is connect wallet, and the other one is about the private key. You generate a private key, and then you could set it here, and then we make a double security mechanism. We have to secure or encrypt your private key locally. This is the passcode, and then when you register an account on layer 2, that you have an alias. You need to register an alias. All the alias are unique. You could send to others by the recipient's alias directly. Yeah, this is what it looks like. And you could deposit here, and also you could send. Oh, oops. Our architecture supports currently that only support Mina token, but in a roadmap our architecture have the potential to support custom token too. When you trigger deposit and then enter how many Mina you want to deposit, and then you will trigger auto cache to make a transaction, and then it will show the transaction here too, and also your balance updated. You could also send to others. And then you need to input the local passcode to decrypt the private key again, and then it will send to. And this is the withdraw. We forgot. We don't change the letter, the word. This is the layer 1 address. These are all the basic features of Cache, the first entry point of Anomix Network. Okay, these are the brief introduction. Okay. I saw a question at the comment chat on the chat bar. Open source my code. Okay. Oh, oops. I forgot to open source it. I thought my teammate open source it. Let me see.
I don't think you have to do it now, but just for having it ready for sure, because it will require Apache to license.
Pardon?
Each project is required for Apache 2.0 license, which I'll just put here. But not now, but after. So for now, it's okay. But after the call, then yes, please.
Okay, I will open source it. I thought I have had the open source it, but not yet. Yes. And any other questions for my project?
I present Mina. It was basically a side project for Cohort 0. I developed a metaverse game, and I went in a little bit trouble to constantly upload stuff to Berkeley and so on. And then I built out a small helper class. And for Cohort 1, I thought, yeah, maybe it's an interesting small proposal to focus on this helper class and make it more accessible for other developers. And the claim was set up a basic mini project in less than 5 minutes to enable quick testing cycles. But before I go into what I have done, maybe why and why now, and what is my motivation behind it. My first motivation is next year in April, the Bitcoin halving is happening for the 4th time. And normally we see 6 months later a bull run. And can you see my mouse? I don't know. I started 10 years ago, and in my experience in the bull run, new people come into the field and check out blockchains and so on. And I expect this also for the next bull run. And this is a big opportunity for Mina to get more developers into the ecosystem. The next motivation is we are facing an AI crisis. And I think that blockchain in combination with zk tech can solve some of the problems. And next year are also the elections in the US and in November. And I think the world will look to zero knowledge proofs next year and hope that we can deliver something. And other motivation or other belief is Mina needs an ERC20 moment. What I mean by that is like Ethereum created the standard ERC20, and you only need these 3 lines of code to generate a token, a minimal token. And out of this token, the whole DeFi ecosystem involves out of it. And we have to build out structures that we can deliver something in the future if a standard come out which blows up and help the Mina ecosystem to get bigger. Yeah, in summary, in 6 months the halving is started. I think in 1 year we have the bull run, and the elections will also help zk to grow extreme. And we need Mina. We need Mina to help our democracies to fight against deepfakes and so on. Yeah, okay. What can I do as a small developer? I can create a tool that people can faster learn about zk, and this is what I did in the what I said in the proposal. What I have to do. I only have had calculated 4 weeks for that project. I mean, I invested six weeks to 8 weeks, but not the full 3 months. The proposal only was for 4 weeks. What I did is I made a research in high growth applications. I also published it on the zkIgnite side. And my hope is that we figure out how zk oracles work, and in the roadmap there is a TLS, I think TLS feature, and this could generate an ERC20 moment, but I'm not sure. But it's my bet, you know. But yeah, I did also a lot of user interviews and so on. But these are the 3 fields I think look out to, where a lot of new developers come into the ecosystem. I also made a user grouping, and I thought, we have a tool, zkApp, CLI. This was also a criticism in the comments. Yeah, we have zkApp, CLI, and why we need another tool. Yeah, basically what I decided is I focusing on newcomers, not on the full stack zero knowledge experts and so on. These people can use the zkApp. I want to make it easy, very easy. This is also the name. And if you look here, this should be the goal, you know, like bring new developers in, and then they can later use zkApp or other tools, what they want. I also made I made a user research. You can find it on the proposal. Yeah, let's get started. Basically, if you want to get started with the module, it's very easy. You type in npm init and install ECMina, and you need these 3 lines of code. I can later make a demo, but I want to go through the features a little bit more structured. What ECMina does is it generates a minimal folder structure. The minimal folders you need, that everything is set up in an easy way, in an easy understandable way. You have basically 2 important folders here. The Mina credentials folder, where all your securities are inside. This folder is also visible, and it's connected with a gitignore file. In the gitignore file has to be the Mina credentials file, that if a developer accidentally upload the code to GitHub without thinking on ignoring the credentials, ECMina thought about it and inserted it into the gitignore file. And here are all the accounts inside, and all the contracts. Is also a nice visualization in the terminal. And the credentials are in a special form here, stored in a special form. You have this, currently it's called meta key, which are not security relevant informations inside, and then the data field. And this was not in the milestones, but I have also created a encryption class. It's not fully functional right now, but later maybe this part with the private keys inside will encrypt it. Yeah, and if you deploy a smart contract, also the smart contract will store it in a special format. And you have also the smart contract, the source code inside, and yeah, all other relevant informations. Then also a small example will also generated with the correct tsconfig, with the correct TypeScript file that it works. Here you can see the directories and so on. You can, if you wish, you can change the directory names, but the tsconfig file is always correct. Yeah, and then what I did is I see this proposal as a starting point, and I thought really deeply about the structure and how to go forward and make it extendable, and yeah, how is the right way to present it and make a task abstraction that maybe I can later also publish separate parts of Easy Mina. Yeah, separate. This would be very interesting. For example, the GraphQL part would be interesting as a separate class, or the encryption part would be interesting as a separate class to install over npm. Yeah, and what I also did is I created all these classes, but in the end you only import this Easy Mina class, and these classes, all the classes have one config file together, and this was also important. I learned this in the last years. That is a very nice feature to have, because if you have one config file, you can generate very nice documentations out of it. And this is what I did. I connected this config file to the Jekyll Ruby site generator, and I built out a site generator class, and yeah, and then I generated the options and the overview. We go to github.io. You can see here the website. And for me, it was important that everything is on the website. All the informations, all the defaults, all the validation, all the types, and so on is here. And you can click and get. If you have a question, you will find here some answers. And this is, I think, also very important especially if you work with beginners. And yeah, and this was the challenge, to bring the class together with the documentation. And I also talked with Yasin, and we discussed if it's maybe interesting to internationalize, make it multilingual, and it's also inserted. Currently, it's only English is available. But I don't know, 60% or so is ready to go multilingual. In the config file, everywhere you can see, everywhere it's a string. There's a separate key for English and so on, and you can, yeah, I thought about it, and this is maybe one of the next steps. Yeah, and then I made a really deep explanation what's going on with the methods, and after that, yeah, I created some tutorials. And currently only 2 tutorials: set up your environment and deploy a smart contract. And the code is pretty simple. This is everything you need. You can insert a lot of parameters if you want, but this is it's a starting point to to get your first zk contract uploaded to the Mina blockchain. And yeah, the next steps are, I also created a feedback form and try to spread the word and get feedback from the users. It's very hard I always think if I build a project like this, I think like building a engine, you know, like you have to go to a certain point until you can try out the engine. And right now I'm on a point that you can try out the code. You can download it from npm. You can generate your first code. It's not perfect, but you have also validation. You get error messages, good error messages. You get you have a documentation. I can refer to a documentation, and yeah, this is like the first step to go forward with it. And in the building phase, I also made more than I had to do for to make the milestones work. I also implemented account encryption. This is 80% ready. Internationalization 60% ready. Tutorial importer. This is a big thing for the future, that you can easily import multiple files, a smart contract and interaction file, and this is a really nice tool for lectures, I think. And yeah, and then chaining and internal state management, and all out of these ideas, out of this work, a lot of new ideas come out, and currently I'm discussing address pattern finders and a contract naming system. This is also what I thought this is needed maybe for the future. And yeah, it was a lot of fun to build the small project. Do you have questions?
I might start maybe not with a question, but with wow.
It's
great. I think it's an amazing. So I did actually have a similar feeling for the. I actually had I actually had a similar experience when I was showing to someone zkApp CLI, and they get confused from the first time because there's too many files that are generated. They were like a bit too much. So that's great. You actually tackled that, and I think it's very useful. The documentation you've made, yeah, that's great to see. As I guess the small feedback in the documentation section on the left side, you have A, B, and the like names of the functions. That looks a bit like the options. That it's not that maybe straightforward to follow. Console spaces standard. What is console spaces standard, and can I duplicate it? So that kind of got me confused. But other than that, just the point that you have documentation for such a tool, I think very, very, very useful, and it's something to build upon a lot.
Thank you. Yeah, I had last year I had a conversation with a very, very good developer, and he made his first start in the blockchain, and he said, yeah, blockchain is fun, but a lot of tooling.
Totally agree.
And this is what he talked about Ethereum, but Mina has more tooling already with the verification keys, and then the smart contract is off chain. Yeah, you have a lot of moving parts, and yeah, and it's tough, but I'm really happy to start on this grounding block. You know, like do it right with this generation of the accounts. Right now, I think about maybe give the accounts also names. You know, like Alice, Bob, and so on. Then you could write tests and can say Alice sent this and that to Bob. Bob, do this and that. You know, and this is like, but you have to start somewhere.
Yeah, you're right. Actually, thinking about it, with a local blockchain with a test account, we just go by index. Why not just go by Alice and Bob name? That's actually a good idea. I think that's, again, makes it way easier for people to understand.
And would be easier to work with also with the designers too. You know, like with the user experience designers. You know. Yeah. But other questions or feedback? Give feedback also, please. Feedback. If you also with the try it out, and yeah, yes.
Yeah, my feedback and also like appreciation actually. I really love your mindset on a community-driven approach. You know, like as anytime we talk about, you're always thinking like how we can onboard this group or how we can help them accelerate the learning curve. So I will love to like go in detail and just, you know, we will have these community preview meetups with the community, and I hope this tool can turn into like a really powerful onboarding mechanism for lots of developers. Not, as you say, not only ZK, but like TypeScript developers or Web2 developers. I think it has a huge potential, and again, well done, and keep having this community-driven mindset, which is awesome. Yeah.
Thank you. I really appreciate it.
Yeah, I'll just double down on in saying that in the last session we saw Arnaud's Mina playground as well, and I think between this capture the flag and Mina playground, we're going to have like an interesting suite of tools as like developers are coming in for the next cohort. So I'm really looking forward when we follow up as well to like think about what the best way to position all of these tools and like kind of as a suite, and not as a suite of like standalone products, but just like I think now for the first time we have a real kind of a strong development environment that we can hand to people outside of obviously like I think we should assume that the docs are going to continue to be a struggling point in the short term, and so I think having the community keep things going until that gets better is like a pretty solid place to be.
Yeah, in one of my proposals for cohort 2, we discussed this also in the comments, how we can, or one idea was how we can connect Mina playground to Easy Mina.
But that would be really interesting.
I have to look into it.
Yeah, well, he gave a full demo today, so maybe what we can also do is we can make sure that you see the demo that he put together too, just in the short term, because I think it's he did a great demo.
Great, thank you very much, and thank you very much for everybody attending and listening to me and Vincent talking for half an hour. We really appreciate that. So FlexSecure. The idea of the project was, just to iterate again, was to enhance flexibility, electricity flexibility, delivery settlement using zero knowledge proof. So let's introduce again a bit the transformation in the energy sector. So the energy system is undergoing quite a massive transformation driven generally by 3 key factors: decarbonization, decentralization, and digitalization. Traditionally, electricity generation relies on large power plants and high voltage transmission networks with distribution through voltage networks to consumer. Well, now the future electricity system will shift towards small-scale generation that's closer to consumers, which is motivated by ambitious renewable energy targets at, for example, the European Union level. So up to 50% of new renewable installations in 16 European countries are expected to be connected to the distribution network by 2030, which is quite a lot. And electricity consumption patterns, therefore, will change, with more consumers generating their own electricity or adopting EVs or maybe using heat pumps. Having said that, policy supporting electrification and sector coupling will facilitate this shift, which will lead to maybe a predicted 20% increase in electricity demand across Europe by 2030. So flexibility, if you want to define it, is the ability of an energy asset to shift its consumption or generation in reaction to external signals. In the energy sector, it ensures reliable response to changes in electricity supply and demand. So this can be achieved to flexible power plants, energy storage, demand response, or interconnection between power grids, how we see interconnections between, for example, UK and the EU. Decentralized energy systems with distributed energy resources also contribute to flexibility by adapting production to local conditions. Digital technologies like smart grids and advanced analytics, they play a key role in emerging flexibility. And having said all this, a flexibility market facilitates trading of flexibility services among stakeholders, thus optimizing their grid balance and supporting renewable integration at a distribution network operation level. So what problems have we identified and what was the motivation behind the work? Well, there are cybersecurity constraints in a high volume transaction environment when it comes to flexibility. There's data sensitivity and we have consumer data at risk. We have a locked-in data and lack of transparency over flexibility transactions. And there's a lack of standardized data formats and solutions for all customers. All those combined, they are contributing towards an increased market barrier for flexibility prosumers that we are hoping to manage to break and lower, so more and more consumers will be able to take part in the flexibility process. So what were our data requirements for this? So before going into the text, actually, let's start with the text and then I'll explain the graphics. So, of course, data is crucial for settling flexibility in energy markets, including demand, generation, weather, and contextual information. Smart meters, like what we use in the UK called SMETS2, what you can see on the upper right-hand side, they play a key role by providing detailed energy consumption data and enabling two-way communications. The baseline energy profile of an energy asset is vital, which is calculated from historical data to show non-flexible conditions and determine deliver flexibility accurately. On the other hand, the deliver flexibility is calculated by comparing the actual energy profile during the flexibility event with the baseline, which requires precise and granular data handling to ensure accuracy. Having said that, robust data handling procedures and a capable system are needed for reconciliation and verification. The UK's and EU's commitment to a more flexible and sustainable energy system is evident through the widespread development of all those smart meters, which in the UK, there are those SMETS2. So how does our system look like? Well, let's start with the upper left-hand side diagram. You have three players in this flexibility system. You have the regulator, the network operator, which in here we just reference as the DNO, distribution network operator, and the flexibility prosumer. So the relationship between them is as follows. The regulator regulates the DNO, which then reports back to him. And then the flexibility prosumer sends flexibility to the DNO, which then buys it. The relationship with the flexibility market, again, is as follows. The regulation has an overview of the market. The DNO manages the market, and the prosumer finds the market for as a new opportunity for a revenue stream. So if we move on the upper right-hand side, so the flexibility prosumer has a flexibility asset smart meter. It commits that data, it commits to flexibility data location, which then gets uploaded into a decentralized data storage. From that, we are issuing a proof that confirms the delivery of flexibility. The DNO accepts the zero knowledge proof, and this is how the flexibility gets settled. So in a bit more details, we have the diagram on the left-hand side that I will not focus on right now at the moment, but let's go again through the step-by-step. So on the bottom right-hand side, the flexibility prosumer records the flexibility data in a decentralized data storage environment. Once the DNO requires the settlement of delivery, zero-knowledge proofs are used to generate two proofs. Firstly, we need to generate that the correct data has been uploaded into the decentralized storage. And secondly, we need to give them the baseline actual energy profile, the baseline minus actual energy profile, to make sure that the baseline minus actual energy profile is equal to the amount of flexibility delivered. If it is equal, then it means that the prosumer, the DNO can settle the contract and remunerate the flexibility prosumer. If it's not valid, then the DNO can apply penalty, and then you can get more details into why the flexibility or the energy has not been delivered. Maybe Vincent can go through this slide.
Yes, I'm going to be scourged with words. My throat is not as it's meant to be. The contract setup is composed of 3 contracts right now. The factory of one, which would be owned by the DNO, which is capable of adding both the asset and the flexibility contract. And the diagram on the left, that's how the setup would look like. So in a way, is that the device would read well, it doesn't have to be electricity, but say electricity reading, it would sign them, and then it would provide them to the asset owner, and the asset owner would build a proof out of it. So it's AirGap, like, I mean, it's not exactly AirGap because there would be BLE reading, I suppose, or other wireless device protocol, but the device by the DNO would not be able to stream any electricity data. It would give you stuff which you can use to build a proof. So you can prove that you fulfilled your contractual obligation, but the data could only come from an approved device, so you yourself couldn't fake it. So there's a bit for both parties.
Great, thank you very much, Vincent. I'll carry on with the next slide. So of course, because this is an energy project, we need to test it. So we need to develop a test case. So for this test case, we have developed a simple energy network that has a small neighborhood of 6 houses that each has flexibility assets connected to a substation. We have presumed that each house has a solar panel and a battery under the form of an electric vehicle. On the right-hand side, you can see the baseline and the actual energy profile for one asset, for the battery, and for the PV system. So the first thing that has to be done was to aggregate the data. So we have aggregated the total flexibility capacity for the PV and for the battery, for the baseline, and then for the actual energy profile. Then each of those flexibility providers or the flexibility assets, they are bit into flexibility contracts. And we can see here that for all the bits for each contract, and the way we have cleared the market, we have done a closed auction price-based clearance, where in simple terms, we just cleared by the cheapest price. So contract 1 was won by asset 1, contract 2 was won by asset 4, and then contract 3 was won by asset 6. So those are the results. So here we are seeing the flexibility bits for every half an hour. So our software has a half an hour granularity, which matches the data that comes out of the smart meter. And we can see how much flexibility has been bit at every half an hour with a constant price, estimation of, estimating a constant price per kilowatt. So if we look at the bottom, we can see now the deliver flexibility. So the winning bits has been awarded the contract, and now we have seen that. So if you are following the blue area with the blue area with the yellow line, we can see that everything matches. So at every half an hour, the deliver flexibility matches with the required flexibility, and you can check that for the rest of the color. Maybe the visualization has not been the best, but I don't want this to be a 50 slides presentation. Okay, so everything looks. I think that everything sounds very nice, very interesting. But actually, what have we actually done? So I think it's very important. So what I wanted to get out of this project, letting me on the fact that this is an important problem, it has to be solved. The other very important part is to share our knowledge. and firstly to share our knowledge with you. So for that, we have been an extensive report that I'm going to go through now. But also to share our knowledge with the Mina community and then with the world. So for that, I will get to that stage when we are going to towards the end of the presentation. But now, if I can scan through the reports with you, we are not going to go through the reports in a lot of details because it's 30 pages. So what? If I can just zoom in a bit. Okay, so let me explain to you a bit of the structure of the report and why is it important. So firstly, we gave an overview of the transformation of the energy sector. So we've described what I described in the first slide. Then we gave an introduction of flexibility markets. So what are flexibility? Why are the markets important? Where do they sit in the energy sector? We have explained the roles, all the key stakeholders in the flexibility market. Then we have explained exactly the type of flexibility services that are being contracted in a flexibility market. We have given you more information about that. And then we have jumped into actually step-by-step process of contracting this flexibility, which is referenced with the diagram. So if you look at this figure here, so this is important. You have the 4 types of services that are being contracted, and then all of those are individual steps in the flexibility contracting process. So here we've described how this project, we are looking at delivery and settlement. Now we need to look into challenges and blockchain opportunities for flexibility markets. So we have described the challenges and the opportunities, and we have also given a diagram. Then we jumped into the delivery settlement and zero knowledge proof. So we explained the delivery settlement process. So in here we have explained the challenges with the current flexibility delivery settlement process. So some of the figures you can see from the presentation. The data requirements, as explained in here, we are also giving our, well, quite obvious but important mathematical equation for how the flexibility is being calculated. And then we are going through the zero knowledge proof approach toward digitalization and flexibility delivery settlement process. The actor interaction and how does the code work. In the end, we are again describing the energy network, so the test case. And here we have all the results, so we want it to be quite extensive. So we put all the results, all the initial preliminary assumptions here. So the aggregated results, and then we have the price beats, we have the flexibility beats and the required flexibility, and then ended up with the delivery of flexibility. And so we did an escrow mechanism as well, which was a bit out of scope, but we thought it's quite nice to have. More information and exactly how that works is available here. And then we ended up with the conclusion, and then we wanted to give some recommendation for if this project by us or by anyone else will have to be picked up in the future. Those are our recommendations, and this is what we have found while we are working towards it. Yes, so this was the report, and now maybe Vincent, you can share your screens and we can go through the code.
Yeah, sure. Give me 1 second. Okay, that's the right screen. Okay, so let me build it around the tests again. I will work, but it takes some time. So while it's doing it, I'll take you through what's in here. So as I said, there were 3 contracts. So that's okay, wrong one. At the highest level is the factory. So that would be owned and operated by a given regional DNO. It's once you get past initializing, setting admin, daily admin functions, they have option of registering an asset, which would be like a plant or a solar PV farm or a battery. And they have an option of creating a flexibility contract. Doing that will spawn this contract, which is the flexibility one. So the top on it in the fields are when is the expected time is going to start. And so what you do is you have a period within which you're meant to be like on call, and you're told sometime early, just like, I turn on. So that would be set by them within that given window for which you have to be available. So there's a start time, end time, power left to deliver. Winner is the asset, which is the next one we'll go to, which won it. Admin is the DNO, and submission counter, I'll get to it later. So let's get to the asset. Asset's a bit simpler. asset has the owner, power capacity, and approved signer. So approved signer, that's the interesting one. That is basically the device that the DNO has provided, which can sign, and their technician would have installed and physically attached to the wires, and that thing is reading. So the requirement is that it has to provide a reading every half an hour, but the actual readings are every minute. And of course, you don't know, maybe a different DNO has different requirements. So what happens is that we have a scale of readings that can be really any, it doesn't matter, but I've made it for 1 minute in those tests I just run. So what happens is there's every 30 minutes, there's going to be a block submitted. And within that block, there is 30 1-minute intervals. And within that 1-minute interval, each one has the power output for that 1 minute and the ISO timestamp. So within that asset, it just initializes. So we have an option here for the future to use ZK oracles to make it sure that when DNO sets it up, the values set in here actually come from a website, which from the hash of the hash of the stuff on the website matches, but that's not implemented now. We set the owner, who's the person of it, who could in theory transfer to someone else, and they're going to get paid as well. The DNO sets the approved device, which they will know that they're into that person, and then expected power capacity. And the functions are that I can bid on a contract, which would be the one that is listed and created by the factory contract. So let's go back to the flex. Yes. And yeah, this is a flexibility contract. So in here, you would set the start and end time and the power left to deliver. And the bid would be called by the person willing to partake in that process. So we have a function called set winner, because at the end of the day, the DNO can choose it not based just on financial terms. It could be other considerations they have, like the location or security or whatever else they think convenient. We have written a function that uses events and reducers to pretty much loop over the bids and pick one. So if a DNO is very lazy, they could use that. It's commented in because we run out of the fields. So if there's two of them, they could have been packed together and that would be fine. But in real world at the moment, like they kind of pick it by hand, so it's not actually necessary. That's actually yes, let's show you like this. Okay, okay, so set winner would be called by them. And what happens is now that owner or their device, because I'm assuming there would be it'll be hands-free, they wouldn't have to do anything, but there'll be a link between the device taking the reading and then device, which could be, I don't know, your phone or your PC that takes those readings, but you would have to pretty much call that function. And what that function takes is a delivery struct, which contains a single signature and then two arrays. They're 13 size. That's defined in else, but it's 30. So I'm not sure that should be kilowatt hours, but let's just say this. So you have 30 readings corresponding to that output for that period and 30 timestamps. And then, yes, anyone can provide it. It would probably be the person because they would have an access to it, but it wouldn't be the actual device doing it. We would just get it from that device. So delivering update. So I am basically extracting here who the approved signer is. So basically from the asset that won is going to have an approved device. We're getting that approved device. We're checking the times, which is meant to start and end. They're needed to basically work out the blocks. So the attack types would be that I could reuse a given block and substitute it for another one. So I do lots of calculation, which trip me up a lot, where I calculate the offset. So if there's a given start time, the first block is going to be a 0, the next one is going to be 0 plus 30 minutes, and the one after so on. So this is the block offset. Minute offset is basically the offset within that block, which has the individual reading minute by minute. I look for the limits, which is like there's a window. So I mean, that could be a bit narrower, but pretty much anywhere in the middle of that minute plus 20 seconds is fine. There is no drift because that's calculated not based on the last reading provided, but of the ideal one. So you have to follow on that window. I think I've run it with 10 seconds. It was fine as well. I mean, it's okay. And here's a loop. It's not remainder. That's not the right word, but I chose one. I'll say what it is in a second. So I had a few issues and I solved it by turning to Unit 64. So that's what's happening here. But I'm pretty much asserting that the timestamp, which is in seconds, not milliseconds, which also confused me, is within the range of limit high and limit low. I am setting the next minute offset for the next loop, and I'm also setting the limits for the next reading batch. And I'm so this is actually necessary, because what we're doing is, from the total amount of energy you're contracted from, we're subtracting from it. So imagine you got 10 kilowatt hours or 10,000, and then you're slowly draining it. But we've left the field just for future, in case you're contracted not only to drop it all in one go, you can also have like a minimum amount necessary. So this is basically in that minute block that you have a minimum reading of something, it's set to it's milliseconds in the moment. I realized we had a problem that sometimes it would drop a bit quickly to 0, and I'll get a buffer overflow. So the remainder, which is not a remainder, but I'm pretty much checking that if I was to subtract it, would I exceed how much there is left? And if so, then I'm setting the latest reading to be that amount rather than what was actually read, so it doesn't crash. And power left to deliver is we're subtracting from this local variable. Then the local variable gets set in a contract. So upon the next invocation, you have less of that energy to deliver. I'm incrementing the counter. So this is pretty much the counter is how many of these 30 minutes windows you have. So if you have 10 of them, then it's going to be 5 hours, right? Yes. And it's just to prevent people trying to resubmit with the same readings. And here's pretty much the check, which says that the provided hours, the minimum power levels, which we subtract from, which are a little bit above, and the timestamps have been signed by the approved device, which is not the person submitting, but the one that the DNO is very much happy with. And okay, that's it. So that will pretty much go to the next bit. I'll show you the test that's running it. So let's go from the top. So just keys that are going to be used throughout it. I'm compiling, deploying, the usual stuff. This is the function that creates the readings. So at the moment, I do have those readings, but I couldn't actually get them to read them because of JSON stuff. So it's a little bit convoluted. So they're kind of constant values, but how the limits work and how it's subtracted is actually fine. That does make a little difference. But in a final repo, I will actually have it read with the actual data. It's just I couldn't get it done for the demo. Updates the admin. So yeah, it was just swapping out the admin in it. Creates asset smart contracts. So yeah, someone has submitted an application all Web2 saying, I got that asset, can you add me? Someone goes in, verifies, he gets the paperwork done, and if so, the DNO can approve that person, and that person can bid on contracts. Okay, sorry, that's what the asset submission was. This one. Sorry, so it's the asset smart contract. Okay. So here we are doing 3 separate addresses that are going to 3 separate flexibility contracts. Yes, that's it. They all start at the same time. Those are the watts. So those are test values. The ones, well, actually, there's just some values that the data, I can't actually open it now, had the actual graph because it varies. It's not like, flat out, but I didn't manage to get it to load, but that was just a JavaScript thing, not Mina. I registered the flexibility contract under the factory. Yes, there's a little bit of to-dos. I bid on the smart contract as each of the people. So yeah, as I assert the winner, so that's just the admin account just calls the set winner function and picks a random asset. And I'm testing all the batches here. There's some logging going on, but so number of submissions are basically calculated, the end time and the start time. There's 30 minutes, 60 seconds in each. I use UTC timestamps in seconds to get that resolution of 1 minute, which would be quite nice, that's what they actually have. I create those readings, so I mean I can change that. So it's just gonna drain it faster. That is just what would be the each minute reading within that block. So it's going to be the same for all of them. And what we're saying is that the next reading is going to have a different start times. Create a struct, which is going to be consumed and verified, which gets signed in this reading as well. That's why I'm passing the approved key, and those value pairs are signed. I'm submitting it for each. So I'm looping over for each of the asset types and submitting the data on the behalf of the owner. And then at the end, I am checking that the power left to deliver has decrementing. So he was in the previous one, it was slowly going down. So I think it was using quite big values here. It's just slowly draining down. And yeah, that's it. There was one more thing that we wanted to have, which was that there is a functionality for an escrow, as in if you for the asset, if you do not provide those values, then you fail. If you don't provide over half an hour, you fail. But there was no, so we do have. So let's go to Flex. The energy that you're contracted to deliver is here, right? And that just goes down to 0. But what we need to have is a token which gets put in by the DNO. It sits at the escrow, and upon you contractually fulfilling it, then trustlessly, you as an asset owner, you can take it out. If you don't deliver, you can't, and then the DNO gets it back. So we had tokens here, but it just didn't get quite to getting it. But the actual logic is there. And yeah, that's it from me. Thank you for listening.
Great, thank you, and cheers, Vince. Let me just share my screen again to wrap it up. So, okay. Great. So, okay. So that's it. As you can see, it's a bit hard to explain this in code. So I would encourage everyone to go and read the 40 pages report. But what are the future steps? So we have delivered all the milestones, except of the front end. So we came to the conclusion that this is now required, as this solution will have to be integrated with the existing OT operation and infrastructure technology of the network operator. So for that, having a front end would be nice to have, but not you wouldn't add any value to the project. Secondly, we have come to the conclusion that the energy sector is very traditional in the way they are handling innovation and new solutions. Industry, which I mean technologically, and people, as in their mentality, they are not ready for this just yet. I think it will be extremely hard. Based on my previous academic and professional experiences, it would be extremely hard to sell the solution to a network operator. I think what has to be done is to basically let them know about it, prove that it worked, and slowly talk them into it. But this is a lengthy and a complicated process. So we want you to engage with us on the report. So we are ready to take in any comments or any clarification to improve the report, and to then to improve the report and then to define it. And as I said previously, so I think it's important to share those findings with you and with the Mina community, but I think it's mostly important to share the findings with the world. So for that, we are aiming to write a journal or a conference research paper to basically share the findings of the process. And I think this will be very interesting, as you will the project will be acknowledged in the research community, and more people will have access to the logic and to what the project is about, and more people can actually build on it. And I think this enhances the opportunity, if that's probably not a word, of the project, and our mentality towards it. But in the end, I'd like to say many thanks to everyone for many thanks to you for listening. Many thanks to Mina for making it possible, and also many thanks to Yasin for for dealing with all of us. I expect it was not very easy. So thank you very much, all of you, for this. And yes, any questions? I'm going to any questions?
Thank you, Nicholas, and I think you have been doing a great job. So I'm also very interested in these kind of industries and how to disrupt. So definitely worth to chat afterwards, how we can turn these traditional industries to more innovative and technology-oriented areas. Yeah.
Absolutely.
Sorry if I just might add one thing. I think Nicholas mentioned it, that with the current contract setup, it's not, you don't only have to use it to prove you've delivered energy, but that you didn't use any. So in theory, at a house level, I could buy a contract. I'm not going to boil kettle at 9 a.m. and draw the grid. So in theory, you could have a spillover onto the smaller users of the grid.
Absolutely. Yeah.
And also, I saw some Patrick's comments. Do you want to chime in, Patrick, to share your idea or strategy?
Well, I think with Vincent, we briefly discussed this, that it's indeed hard to get to these traditional industries, but I think it's like they are really into something and look for this like maybe small and innovative new companies, like, and also like wind farms, wind energy farms, and especially companies who are developing sort of like betting solutions. At least in the Nordics, there are a couple. So that's something that we chatted about, that maybe some like energy startups might be willing to bit like experiment, but indeed it's like conservative industry. But yeah, I really like the presentation and all the work. So great work.
Thank you. We appreciate it very much. Thank you very much, Patrick and Yasin. Thank you.
And maybe, yeah.
Please, Andreas, go on, please.
Yeah. I also think this is a great job what you have done, and don't give up on the idea. I can only tell you from my personal experience. I worked in 2015 for an accelerator, and I met a lot of normally you think an accelerator, they have like many companies and so on. But if you are in the right circle of people, you get contacts to people, they waiting for special companies, you know, like these special angel investors and family offices. Here in Germany, we have family offices. And if you only need one good angel investor, and he opens you the door. I know these I met some people, and I saw what they can do for companies, you know, like they have, let's say, 25% on a company, and an important company, and they say this company had to, I support this company, this small startup, give them a try, and they will give you a try. You have to find the right investor, and I think for your idea, this is a multi-million-dollar idea. Don't give up on it. You know, like this is a big chance in your life to change your life, and I think the team is very good. I saw the code is very nice, and you're good in research. Find the right people, go to the events, go to big cities and to the events, and try to get in contact, shake hands, and talk to people.
Thank you very much, Andreas. I will not take your advice lightly. Thank you very much. Really appreciate that.
Thank you very much.
You're welcome.
So Patrick has asked about defense use case. So I mentioned the other one thing I wanted to add is that with Mina, we could have added it in such a way that whoever won the bid is not certain until it's after delivered. So you can actually mask the delivery until it's done. And when it's done, you have a proof that you've done it. So you can't, ahead of the delivery, find publicly where the asset is and then find all of them and try to cause disruption by targeting them all at once. So that's something we kind of looked at, and I think it's possible with Mina. It's just didn't have the time to flesh it out.
And in addition, the regulation, firstly the regulation and then the standards that they have in place, or what we call a black start or a discontinuous supply of electricity or energy in our country. They are there for quite a lot of years, and they are extremely extremely regulated. There's a lot of barriers to probably look into that with an innovation solution. But thank you very much, Patrick. I need to read the link. Thank you very much. I really appreciate it.
I'm just going to pull up the code. So basically what we're going to do is I'm going to talk a little bit about the ZK program that we wrote. And then my partner Louis is going to walk through the demo of the deployed app that we have. And then we'll answer questions.
Yeah, okay, so
what we built is Mina Arena, which is a game based on this zero knowledge program. Basically, there are actions, which is the space level struct, and then actions can be processed, and there are levels of processing. I'll kind of just walk through the README and start with that. So the base unit in the game is called a piece, and a piece has these fields. Notably, it has a position, which is an XY coordinate on a rectangular game board, and it has a condition, which is sort of all of the stats within the context of the game. And the condition is initialized from a unit stats, so it sort of has this hard, I'm losing my word, but it has like a permanent statistic, and it has a temporary statistic, which would allow for things like buffing. The only way we're using it now is reducing health. But you can imagine different temporary changes to the piece condition within the context of a game. So these are all sort of the values that we're tracking. And then the game state has a pieces Merkle tree and an arena Merkle tree. The pieces is a root hash where each piece hashes itself. And if you just, basically when you start a game, you assign a piece an index in this hash, in this root, in this tree. And you hash the value, and then you hash them all together into the pieces root. And that's how you can make assertions about the validity of the pieces in the game. And there's also a Merkle tree for the arena, which is if you imagine that you have this game board with all of these different positions you can go to. Basically, if you order them like row by row, you can come up with an ID, and then we have a Merkle tree, basically just as big as we need. Both of these trees are quite short. We allow up to 32 pieces in a game, and this one is taller. I think that our arena is like 600 by 600. So the Merkle tree is only as tall as needed for that, which is sort of a micro optimization for hashing. And then the way that the state transitions get processed based on these pieces of data is everything starts with an action. And an action belongs to a phase belongs to a turn, and a turn belongs to a game. So an example of an action is we have our piece ID, and we intend to move it from the position where it is to the position where we want to move it to. And then we also have other pieces in the game. So during the course of our turn, we're also going to move this other piece, and we might also move some other piece. And all of those individual actions update the pieces state and the arena state, and the phase tracks those actions recursively. And when your movement phase is over, all of those movements will be processed into the turn, all of the turns get processed into the game, and eventually the game is over. So the phases that we have right now are movement, ranged attack, and melee. And in the future, we could add more different types of phases, stuff like healing or support actions or using an item, or like interesting ideas that we talked about. Yeah, and the way that the proof identifies these action types is just by a field where like 0 means move, 1 means range attack, 2 means melee attack, and the proof kind of branches on that. Yeah, we can get back into this later. I guess I'll quickly just share the code for the phase, because the phase is kind of like a lot of the logic lives. So the phase state is also a struct with these methods apply blank action. So there's move, there's melee attack, and ranged attack. And then the proof just wraps these in a proof. So all of the logic is done here in these structs. So for an apply move action, we accept the action, which is like which piece, which is the new position. I guess that's basically it, maybe a signature. So you have your action signature, your piece, and all of these Merkle witnesses based on trees that you're going to change. So what you need to do is assert that the new position is within the expected movement range of the piece. So we have a verify distance helper for that. You need to verify that the action signature matches the actual components of the action. So the player that is allowed to make this move actually signed their action. you have to assert that the action is coming after the last process action with a nonce, etc. And then the Merkle tree proofs are based on basically making sure that for the key that we're changing, we're making the expected changes, and that for all other keys, nothing has changed, so that we can assert the validity of game state going forward. So that's basically setting the stage for the demo, and I'm going to have Louis, who's my partner. Oh, I better stop. I'll have Louis, who's my partner on this, walk through the game, and the demo is very exciting. It works, it's deployed. Then we can dive into questions later.
Alrighty. I would turn my camera on, but I'm having some camera issues. But I should be able to share my screen. So 1 second. Alrighty, here we go. Okay, yeah, so Kobe took you over how the contract works, how things are validated via proof. So I'm going to take you through a demo of what the game looks like. So this is live right now. So we're going to do it live here. So we've got Mina Arena, a game built on top of the Mina platform. We do have a whole how to play page here with like information about how the game works. Unsurprisingly, this part does not integrate with the Mina platform. So I'm going to kind of gloss over this, but this would take you through how the game works. So if you need to learn how to play. But basically, the first thing that we're going to do is we're going to go up to the user management section here. You can provide your own Mina credentials, but we highly recommend people use our tool to generate a public key. And the reason for that is it creates a gap so that you're not using credentials that are associated with any of your actual assets. So, okay, I generated a new key. So if I go over to the play page here, I can see any games that I have in progress. I just generated a new key, so obviously I'm not going to see it there. Or I can create a new game. So right now, the only game mode that we have available is sandbox mode, where basically I'm going to be controlling both sides. But I'm going to jump into the game. All right, I can see my public key that I'm logged in as. I'm going to go ahead and create the game. And as Kobe was mentioning earlier, so there's like a permanent concept of a game piece and also like your specific concept of one. So here I can see all of the different units that are available in the game to pick from. But a major component here is I'm going to have to draft my own units, and I would then be able to see them here and then use them between multiple games. With the long-term vision being that, you know, I could see that my particular swordsman unit had been used in multiple games and it's leveled up and gotten experience, something like that. So I'm just going to go ahead and draft some units here. I'll just pick a couple. I can see my squad over here that's lined up. I can see I've used up 100 out of 100 of my sort of cost of the units. So I'm going to go ahead and select the squad for my team. I'm now drafting for player 2 in a multiplayer mode. This would hand over control to the other player. And I can see that, again, my units is now empty because I'm the second player now. So I'm just going to go ahead and draft for player 2 here. All right, get some of those. The stabber, John, I don't know, it doesn't matter. We'll pick maybe one of these. Any name you want, and then all of these units. All of these units would then be able to, like I said, be carried over between games. Okay, so I can select my squad. I can see the proposed teams and go ahead and complete the draft and start the game. All right, so we can see the game board here. We can see that it's the red player's turn, and I'm just going to queue up some moves here, and then once I get to the point where I'm making some attacks, I will explain how it integrates with the snarky.js proof. So I can go ahead and submit my phase. I submit it to the server. The server is applying the changes. So all of my moves are validated by passing the game state through that proof that Kobe was talking about. So it applies the proof and validates that your move is in fact valid. I can see the snarky.js information down here, as well as a more human readable readout of what happened up there. So after the movement phase, as Kobe mentioned, we proceed to the shooting phase where I can make ranged attacks. If I'm the red player here, the only unit that I have that can make ranged attacks is my archer, so I can go ahead and queue that up. I can see a readout of like expected output here. Probably not going to do much, but I'll submit my phase. And what's going to happen here when I do this is my browser is going to call out to Mina RNG, which is a previous project that Kobe had worked on, which is a server that can use the Mina platform to generate random numbers and thus dice rolls here. And we're effectively sending our proposed moves to the Mina Arena game server along with encrypted dice rolls that came from that RNG server, which the browser here cannot decrypt. I cannot see the results of the dice rolls, but the server, the Mina Arena server, is able to decrypt those to see what the results were and apply them. So I can see my archer shot at this peasant on the other team. We can see our successful rolls here, and the enemy failed to block the damage. I can see the damage that was done. It was destroyed. I can see the snarky.js information down here. And then I can just proceed. Now there's the melee phase where I can make melee attacks and do a similar thing. It's the same concept as far as snarky.js is concerned. And I'm not going to take us through the whole game, but yeah, I kind of whiffed there. But now it's the blue player's turn, and we would just alternate back and forth, continuing moves until eventually there's only one player left with any units. So yeah, in the interest of time, I won't continue through the whole game, but it would basically just be this repeatedly. Yeah, so I think that's probably a great place to stop the demo, and we can answer any questions.
A lot of love in the chat. Mark and Kobe are kind of having a question around wallet, integrating a wallet. Do you guys want to address that outside of the chat?
Sure, I'll just talk a little bit about our philosophy on this. I think crypto users expect a wallet integration on all their apps, and they're used to the friction that entails. And I'm not really opposed to a wallet. The reason it wasn't a critical path feature for us is that by adding the requirement that you sign every individual piece of data that you sign in the front end with a wallet, that is just really slow. It's really annoying, and it's not something that a non-crypto user expects. And the whole thing that we're trying to explore with this is, can you make a game that is validated with crypto rules, but doesn't feel like that? It doesn't feel like a game that you're playing on Ethereum. There's no cost, there's no transactions. And so maybe there's no wallet. Of course, we're not storing user credentials on our server. We're storing user credentials in users' browsers, which if they clear their cache, they've lost all their pieces. You know, there's definitely downsides to that. It's not something that we've completely explored, but that's sort of our thinking on it. I also want to call out that we are processing the snarky.js code on the back end, but we're not running a proof. Similar to Zen, we built a zk program. It takes super long to compile. We did anticipate running servers. We did anticipate the server cost for that model of operation. but we struggled to deploy it, and I've talked to Raphael Panic a little bit about it. I know that him and Mate are working on something that might be sort of similar. It might be something we could integrate with to do ZK program proofs on the back end on sort of like a layer 2 interface. So fingers crossed on that. Basically, the critical thing that we wanted to do was get this game to work in a way that users could go see, and we could continue to build out more like Snarky.js backend components later. But yeah, the development experience of trying to deploy ZK proofs not running on Mina, the blockchain, but running on like our own server. I guess it was the DevOps expertise part that we didn't anticipate. We did anticipate the cost and maybe the timing, but it turned out to be a little bit more difficult than we expected. So there's that. Yeah, exactly. I'm excited about the model where every team can run their own server. I think that's interesting, but there's not a lot of shared knowledge about that yet. So those are sort of the two places where we did a little bit of shortcutting, but every part of the game, we are verifying a signature that the user created in their browser, and we're running all of the logic of the zero-knowledge proof as a JS component with all the assertions and things that implies. But the ultimate goal that we weren't able to achieve is that we actually create a proof that you can then verify in the blockchain and store like a win-loss ratio associated with your Mina account on the blockchain. So that's something that potentially would be coming later, future cohorts, maybe launching with mainnet, something like that.
It's awesome. I get really excited about this also as an educational tool for new people coming into the ecosystem and understanding the intricacies of Snarky.js with something that they can actually touch and play around with.
Harish, I suppose I could. I always try and shy away from gambling stuff in demo projects because it's obviously unaudited. I don't want to. There are definitely exploits. You could initialize a game that's different than the game that the server created. Like there are some edge cases that we haven't ironed out. But yeah, I mean, maybe in the future it's something that you could stake Mina on the outcome of your game.
First mover advantage for ZK gambling could be huge. Phil Kelly from O1 Labs. If you talk to him, if anyone's talked to him, if he's a big BD guy from O1 Labs, he'll get excited. He's definitely going to probably contact you guys about this. Are there any other kind of like learnings or things that you wanted to share with the group around like things that you picked up along the way that you weren't expecting or that you didn't foresee other than?
Yeah, so the whole game is modeled with a relational database, which I think made a lot of sense for a game. And then when it comes to actually serializing relational data into a proof, that was like oddly tricky for things like if you have a transaction where you make some edits to the data and then you want to roll back the transaction if the proof fails, but then the proof needs to go query things that haven't been saved yet because you're still in your transaction that hasn't been committed. Like I was actually surprised at how complex that turned out to be, and I wonder if a NoSQL database or some other kind of data store would actually be more appropriate, even outside the world of like a shared decentralized data availability layer. Even just hosting our own data, it's potentially true that a relational database is not ideal. But I probably haven't explored that entirely either. Obviously, almost everything we've built here was like a sprint to get there and then like immediately on to the next thing. So we haven't thought everything through in full. But I did sort of notice that being a little bit tricky.
Good to know. Noted.
Arena. Yeah, that should be the URL. If that URL doesn't work for you, let me know. Oh yeah, so it does have to load snarky.js on some of the pages. We tried to wrap that. We try to only load snarky.js exactly where we need to, but you're going to have that like 1 second blip as it loads, depending on what page you go to.
Awesome. Does anyone have any other questions for Kobe or Louis?
There was one other question in the chat here from Haresh. Can you create a battlefield with multiple boards? What would the limit be? Yeah, I mean, terrain and like things that you cannot move through on the board is something that we definitely considered. We didn't include it as part of the V1, like just for the demo, but we already validate via the contract that like a piece cannot collide with another piece, like you can't move on top of another piece. So that concept already exists. So it would just be a matter of like adding the concept of another entity within the game other than a game piece, like a piece of terrain or something like that, that you can't move on or through. And then in terms of like the players being able to set up the terrain before the game, maybe like we take turns setting up where the terrain is or objectives on the board, we can absolutely, the sky's the limit there.
Cheers. Okay, as you can see, my name is Nicholas. Her name is Julia. She's the engineer that has been developing the whole stuff. Maybe switch to the next slide. Maybe something really quickly about ourselves. Our solution is called AirGap solution or AirGap wallet. It basically allows people to turn a spare smartphone into a cold wallet solution, into a cold wallet. by turning off all the connections. It works for iOS and Android. It's already a running solution. There are some benefits from the smartphone itself, like what it provides, like a camera, fingerprint, and so on and so forth. Maybe we switch to the next slide. I try to keep it quite slim, so the main focus afterwards is on the demonstration. The solution itself consists of two parts. We have the vault, which handles the key, and we have the wallet, which is responsible for the transactions. And communication between those two solutions, between those two devices, then works via QR scanning back and forth for the signing. That's roughly like the introduction of the whole AirGap solution. And now we go over to what we handed in for the cohort 1. So we handed in two milestones or two scopes. Standard one, which is to develop an SDK to natively create CTK proofs on Android and iOS mobile devices. That's the one that has been selected. And the broader scope would have been the development of the primitives of the AirGap CoinLib, and then the full implementation into our cold wallet solution, meaning AirGap Vault and AirGap Wallets. Exactly. So maybe we can now go to the next slide. Perfect. So during the whole process, we kind of realized that for the long-term goal of implementing Mina into our full solution, the initial assumption was actually that CK proof generations on mobile devices are essential, but this has to be proven not to be right. So instead of going down that path, we have decided to go one further and deliver something that was part of the advanced part of the advanced scope, was the integration into the CoinLib. Maybe switch to the next one. And here you can basically see what we've delivered. It's an open source CoinLab SDK that provides the essentials for the long-term future for Mina. Like you can do transaction signing, etc., etc. And I think at this point I will hand over to Julia, since it becomes a bit too technical for myself.
Yes, so as already mentioned, the end product here is an open source library that is supposed to serve a great range of community of developers, mostly who would like to deliver wallet kind of solutions. So the sets of the functions of the tools that we provide are mostly aimed to solve any issues that could be encountered during the wallet development. But let me maybe show you what it is about. Unfortunately, since this is a library, the only thing that I can show you is code snippets. But yeah, essentially, the whole library, the whole SDK is available through the NPM registry, and it can be easily downloaded or using the AirGap scoped name Mina. And the very first, and basically the only part that the developer needs to use our Mina-based library or Mina integration in our library is this Mina Protocol that can be easily created with a single factory method called create Mina Protocol, which is configurable with the network options. So the network options are completely optional. If there are none provided, then the protocol will get configured for the mainnet. However, it's completely up to the developer with which network they want to interact with, and they can provide their own configuration to their liking. So for these demo purposes, I've configured the protocol to use the Berkeley public node. So the very first functionality that we deliver with our solution is the keeper derivation from a BIP 39 compliant mnemonic, which means that with a single passphrase, with a single mnemonic, you can basically import and export the same account throughout the different wallets. So, for example, our solution by this functionality is fully compliant with Aura generated accounts, and such an account could be exported via mnemonic and used in our library. And to give you the first example of how it works, here I simply take a mnemonic and create a keeper out of it, and also derive an address, which in the Mina context it is the same as public key, but we also have a function for that. Moving further, the other very essential part of the wallet solution is obviously being able to fetch a balance for the user, and we also provide it with just as a simple method to call that takes a public key as the argument, and it makes under the hood GraphQL requests and returns the value with all the information that is required to make the result human readable. And yeah, as we obviously can see the balance, and we will see some transactions because these are the test accounts that I've already played around with to see if everything is working. The other functionality, and probably the most important one, is to be able to create transactions, create them, sign them, and also send them to the network. And this is also something that we've simplified a lot for the potential users. We divided the whole step of basically submitting the whole transaction into 3 different parts that can work completely independently. So first, the developer has to call a method to prepare an unsigned transaction using the user's public key. The only required parameters that are there besides of the public key is the recipient of the transaction and the amount. There is also an optional field to set the fee for the transaction. However, the simplest example doesn't need one, because under the hood in that method we make a simple fee estimation for the upcoming transaction and use that value to create the proper Mina transaction. And yeah, once it's prepared, the next step would be to sign it with the user's secret key. and only when we get back from that method the signed transaction, we can broadcast it or send it to the node, and that's it. So yes, in response we get the hash of the transaction, and by looking at the Explorer, we can see that the transaction has been submitted and is already pending. And yes, so the last featured functionality that we provide is simply fetching a list of transactions for the user, as this is also something that probably many wallet developers would like to use to enrich their UI, and it uses the Mina Block Explorer API under the hood to fetch the list. And you can already see that there is a couple of transactions that I made yesterday to play with it. Yeah, so that's it from the demo. So let me get back to the presentation. And actually, to wrap it up, because that's mostly it. That was the most essential part of our SDK, of an open source solution that's it keeps growing by many new integrations and is actively maintained and supported by us.
That's fantastic. Well done. Thank you, Yulia. Does anyone have any questions, feedback, thoughts that they'd like to share? Please, Mario.
Yeah, how do you treat transactions when you are offline? Because one thing that Niklas told is that the wallet can work offline too, even when you have no connection. How do you work with transactions when you are offline? You accumulate them and dispatch them later. That's the question, maybe.
Well, that's not exactly the case. So we have two parts of our applications. There's the wallet part, which is supposed to be always online, and there's the vault part, which is the one that is supposed to be always offline to make sure that the user's sensitive data is always secured. And the idea is that the online part, the wallet, prepares everything that requires data fetched from the network, and wraps it into something that's well, essentially readable internally by our applications. Sends it over a QR code to the offline part. The offline part takes it in the context of the transaction. It would be an unsigned transaction that I previously showed in the demo. Takes that transaction, takes the private key that is securely stored on the device, signs it, and sent it back to the online part via a QR code again.
Maybe go back a few slides. There you can see like the overview of the both solutions that have been out there for a while. Julia, just go back a few slides.
Oh yeah, sorry.
It's like a slide number 3 or 4. Yes, this one. And an additional image that I can show how the transaction works, how the transaction process.
Thank you very much.
I think that was my connection.
Yeah, I see. Yeah, I see some questions from Carbonara. Yeah.
Yes, I mean, I was trying to keep the microphone off because it's a bit noisy at times. But so my first question, I see that you developed here implementation of the key pairs and transactions for Mina. And I have two questions. What is the difference between this implementation and the official Mina SDK? And what did you mean with the milestone, the proof development? I was looking at your submission and the proof generation SDK. I wanted to.
Yes, so to answer the first question. Our solution is actually built on top of the official Mina SDK of the on the Mina client, and it basically just adds additional layer of functionalities in comparison to what the Mina client offers. So the client lets you generate a keeper, and so this is the most important difference, that you can generate one, and you cannot import it using a BIP39 mnemonic, and you can use that keeper to sign transactions, as far as I'm aware. What we do additionally, and additionally to the support of BIP39 mnemonics, is that we cover the most important interaction with the node, including the more complex transfer or transaction generation, which requires some back and forth node communication and just fetching data, putting them in the right space, and only then asking the Mina client to sign it. And sorry, does it answer the question?
Okay, and for the second question, so development of the proof generation SDK. This is the proof generation SDK. Is that correct?
Yes.
By proofs, you mean, okay. So the development of generating wallets and sending transactions.
Yes. So the initial assumption was that in order to integrate Mina into this CoinLib and into our AirGap solution, that means into the apps, we will need a solution based on the zk proofs generation, and we already had some experience with zero knowledge proofs, and the burden of generating them on in our applications or in our solution, because this is probably something that hasn't been mentioned, but AirGap is a mobile application written in a hybrid technology called Ionic, which means that the code is actually run in a web view, and a web view is a very restrictive and limited environment. Therefore, for the other projects that was based on these zero knowledge proofs, we had to come up with a native mobile solution that could connect into this web part of our applications. So the most efficiency crucial parts of the whole process could be done in parallel directly on the mobile device instead of going through the web context in the web view. And back to the core of the question, this was the initial assumption that a wallet for Mina would need a pretty much similar solution. Hence, we thought that we would have to create a tailored zk proof generation SDK for the native part to be able to later integrate fully Mina into AirGap. However, during our work, when we started getting to know Mina better, we realized that it's not exactly the scope of the wallet. And since the end goal is to have a wallet solution and to enrich the community with tools for other wallet developers, we decided to switch the focus to something that we think benefits more.
Okay. Yes. Yeah. No, my confusion was regarding the milestones, because yes, on the milestones there were 3 milestones, and it was about the proof generation, and yes, and I see something a little bit different, but that's fine. That's totally fine. Was just for better understanding from my side. Thank you.
And I think, well done, guys. Thanks, Arbanar, for the question. I think we have one more question from Haresh on how the errors are handled. I guess it's a 2-part question. How are the errors handled? And then the second part is, did you roll out your own primitives, and is it audited? I guess it's 3 questions. And then I think after that, we'll probably wrap.
Okay, sorry, my from got crazy for a moment, but I can now open the chat.
No problem.
Oh yes, so since this is an SDK, the error part is mostly propagated up to the end user. We don't want to hide much information. So if there is any network error, which would be mostly the case, maybe there could be something wrong with the mnemonic. Then we simply propagate that error up to the actual user of the library. And well, by own primitives, I guess that we mean that we encapsulated the essentially Mina types or Mina data into something that that is completely compliant with the AirGap solution. So we basically defined some types, some primitives on top of that, so we can, for example, get data from the node, use that data to create a transaction that AirGap knows how to serialize, or a serializer that we wrote that is also part of CoinLib. By the way, we have also some other parts of that library that can be also used by the developers to do more things with the outputs of the protocol methods. So yes, for example, there is this serializer that obviously has to be aware of how to serialize and deserialize certain types in order to make sure that, for example, this QR code-based connection is going to happen between our applications. if we mean primitives by that, then yes, we have a whole bunch of Mina AirGap specific primitives.
Basically, what we see right now is if the end game is TradFi bridging assets, I would consider that losing because they're basically just selling us their stuff, and that's not. Oops, sorry guys, phone call. That's not where we should be. So instead, if we use double entry bookkeeping of off-chain straight, that's kind of how the traditional markets are working right now. We can do what TradFi is doing, but we have the ability to prove it. We have the ability to construct proofs and say this is what's happening off-chain, and then sort of the overall goal of it is the validity of every transaction will be proved. I think just that concept is significant because ultimately what that means is if we have firms that are auditing and whatnot, we no longer need them. So there's a lot of automation that can be done. And we can talk a bit about so what actually are we building here? So zkLedger is a zero knowledge proof of the validity of a double entry bookkeeping system. So, you know, what we can do here is we can provide verification of an accounting system while maintaining privacy. It's fully zero knowledge. And it's actually cool because we'll be able to actually, you know, open up some accounts and then keep other accounts private. So basically, you can think of like if you have an accounting system for the government, you know, as citizens of a government, we would probably want all of that to be public. So we have that option to make it public. But then, you know, if you're running private equity or whatever, you'll want to have a private book, or even like a traditional business, you want a private book. So in that case, we can use a zero knowledge proof. So, you know, the difference between validity and zero knowledge. So what are the components? So the components are a T account, and the T account is basically like just debits and credits. And, you know, one side of the account are debits, and the other side are credits. And there's this specification for it where basically these are the only operations that you can do on a T account. And that's what makes it nice for building a zero knowledge proof, is because you can actually like say, hey, there's actually a formal specification here. So you don't have to like really make anything up. You're just kind of being bound by the laws of the system which already exist. And then you're just saying, okay, now we're going to do it within the context of a snark. So pretty simply, like we have addition, right? So let's say in this state, so X would be your debits, Y would be your credits. And then if we add together one account to another account, we just add the components of debits and we add the components of credits. We have this property called reduced form. Pretty simply, like reduced form, you can think of as, you know, reduction in a fraction. It's actually like this structure is isomorphic to a fraction. So in the same way, like, you know, if you have 2/4 in a fraction, that actually equals 1/2. We have the same property here where you basically subtract the minimum of X and Y from each of the components, and that gets you to your reduced form. Associativity, so, you know, it doesn't really matter what order you add in. There's additive identity. So there's basically zero element, and then it's commutative, meaning it doesn't matter whether you're adding this one or this one first, you get the same thing. And these are also nice to have because you know, like ideas of associativity and commutativity lend to notions of parallelization. So if you have a larger accounting system, you can start optimizing your proof generation based off of these like algebraic structures, and you can kind of construct these higher order methods, which then you can say, okay, this is associative, therefore it doesn't matter what order we do it in, therefore you can parallelize it. And then, so it's sort of the base structure, right? The base elements of an accounting system. Then you have what are called the accounting constraints. So traditionally, you know, we only we only think, I actually need to update these, but traditionally, we consider accounting constraints as assets minus liabilities equals equity. But in my research, basically what I figured out is that this is considered more of a proper system, meaning you can implement this, which is basically saying the sum of the debits minus the sum of the credits equals the value of everything. But essentially what this means is if you were to implement it like this, rather than just constraining yourself to this equation, you can do things like removing, you can remove the liability account, right? So like if you think about Sharia finance or Sharia law, where they don't allow for interest-bearing accounts, you can also think of that as a liability. You can just have assets equal equity, and you can do like compliant Sharia finance just by removing the liability account. Similarly, I was thinking about this idea of the identity account, which is basically you get rid of everything. You just have one T account, and that would be used for bridging of assets and like entity-less organizations. So you essentially construct an LLC, and that LLC has no owners, meaning there's no equity account. There would only be assets, but then you still need to have, debits and credits. So for example, you could debit a treasury bill and you can credit a stable coin, and that would be an architecture for a stable coin. So it's sort of the constraints of the system. So basically these constraints are operating on these T accounts. And point I didn't clarify is, when you have an account, so for example, you would have an asset account or liability account or equity account. These would all be T accounts, and these would all be recursive T accounts, meaning your asset account could be, an array of other T accounts. So it's a T account of T accounts. So it's recursive all the way down. And then actually another thing I discovered was, you have these things called transactions, and transactions will update, the state of your accounts. And you can actually get rid of these accounting constraints as long as if you validate your transactions. So as long as if within every transaction your debits are equaling your credits, then you have these accounting constraints guaranteed, which basically reduces it reduces the amount of checks you have to make sure that your system is valid. You're only validating the initialization of your accounting system, and then you're validating each transaction update to it. And at the end, you're given a valid account for free, basically. So we can go into the implementation. So just so you guys don't have to wait for running the proofs and everything, I have this ready to go, and we can kind of go through what's here in a second. But let's go into. You guys see this? Is it too small, or do you need to make it larger?
We're still looking at the.
I think you're.
Oh, you're still. Oh man, you guys should have told me that, man. I was going through. I had a markdown file that I was.
I pulled up your what you saved in Tarpal on the
for sure.
on the form. So no, it's not all. Yeah, sorry.
Okay,
sorry,
for sure,
we should have
for
said
sure.
something. I just didn't know.
Sorry, guys. Okay, I'm having trouble. Okay, let me see. Let me see if I can share this. I clicked. I see. Okay, MacBook silly. Okay.
Okay, there you
Sweet.
go.
Cool. So we can kind of go through this, and I'll have the tests here, and so okay. So actually, like, this is I have like a work in progress implementation, so that's probably going to be the final one where I'm not using the struct just because like I'm trying to define everything a little bit more generically. That way for users ultimately like building on top of this. I think as Ignacio was talking about, is like some of the type errors are a little bit confusing. And even like when I was building this, I just found myself wanting to just like go into the circuits. So I think, it was nice to like get started. As Ignacio said, it was like, it's good to get started, but then ultimately like when I was trying to do some generic stuff, ultimately like I needed to go back into just like dealing with constraints, right? And it's like the wrappers for like UN32 and UN64, like they just weren't all that useful because they were like, it was just like, it was sort of like blocking in some sense. It was kind of like, it was like, the types from Snarky.js were not like, they didn't have enough flexibility. Even though like everything I was writing was correct, it was still a little bit challenging. But anyways, we can go through this. So scalar T account, pretty simple. You have two elements of fields, debit and credit. We have our identity element, which is just identity, basically is zeroed account. Doing our assert equals, minimizations, an interesting function. We have it here, which is like, as I was saying, reduced form. Basically, this is how you're able to check equality, because essentially, if you're not minimizing, you could have two equal counts. But if you're not minimizing it to reduce form and you check equality, you could have two equal counts, but they wouldn't show up as equal. We have add, we just add the debits to each other. We add the credits to each other. Inverse, we just swap debits and credits, and that's our inverse function. I can kind of show to you here how I did the proofs. Okay, and we did like 2JSON, all the provable stuff that we need to get this system working. And then basically, as I was describing, these things are what are called a Pacioli group, which is just like the operations of a group. So I did some property-based testing just to kind of verify that it is what it says it is. Also, like, when it comes, when it goes to, users being able to add onto the system, having this as a constraint for them to check would be useful. So, here we have additive closure. We're basically just checking like, okay, after you do an addition, it should still be of the same type. Identity, we're just making sure that, when we make an identity, it's equal to the identity. Simple enough. Here, we're just validating that the minimization function works, where it's reduced form, making sure it's commutative, and that it's associative. So that's sort of the base structure that as other people build their own T accounts, they want to be able to validate that they're operating against the specification. And that's sort of where I'm not able to enforce that constraint using struct, because I'm not really like able to make that interface, or maybe I can, and I just haven't figured it out. But that's kind of what I'm doing in terms of like deconstructing everything. So that's sort of the struct, and now we can talk about the actual interesting part, which is how does this actually work? Like okay, cool, we've defined something pretty simple here, but then how do we actually like do interesting stuff with it? So here we're using the zk program to use some recursion to basically be able to pull out proofs of validity, or in this case, actually a zero knowledge proof, but still a validity proof that of the account. So basically what we needed to do is, we needed to add a name to the account, because like if you don't have a name to the account, it's, accounts need names. And then we basically just hash the account. We can see our hash function here. It's pretty simple, where we take our P account struct and we run the hash function, which is here, just beside an hash. And now we hash the name with the hash function, and then ultimately that's our input. Oh, sorry. Actually, not our input, but our input is the name with the T account hash. And the reason we need it like this is so we can actually call the name. But then we'll use this hash within the proofs. So here we can see a couple of methods, init and add. So, for init, we have a private input, which is a salt. And basically, like if we want to make this public, we just remove the salt, and then it's a public account. With the salt, it becomes private. And then pretty simply, our public input, we're taking a name scalar T account, and then private input is a salt. And then all we're doing here is we're just validating, right? We hash the name with the, we're hashing the name with the scalar T, the identity, and we're just making sure that our public hash, which we've defined here, public hash is equal to the init hash. So now I'm here wondering if this is correct, even though my tests are passing. But yeah. Okay. Sorry. I think this is just named a little bit poorly. But basically, what the public hash is, like what should be on. Yeah. Okay. That makes sense. So the T account hash will be this, right? And this is what the user is supplying, and we're basically just saying, okay, did the user actually supply this with the zeroed account? And if they did, then therefore we know that they initialized their account properly. So we can see that here in the tests where we init the account, we init with an init account, which is just, we call it the name field 0. Actually, like I'd like to explore zk, because I think we could do some stuff there in terms of like that would be really useful. So yeah, we just basically initialize the account with our salt and the hash T account name, with our identity. And then all we do is we say, okay, did you actually supply me an account with the name? Do you actually supply me with, the proper name and with the proper salt? And then if you did, you're able to verify the base case. So that all works out. And then here on the add, we're also doing our same thing. We're basically, here's our recursive step, but our public input is the same, name scalar T account. So that means we need to supply, a name and the T account hash, the expected T account hash that we're supposed to have. And then we supply our base case, which is here how we defined it. Therefore, it's our previous proof. And we're also supplying some stuff. So the SNARK will validate, okay, yeah, this guy is actually like giving me correct information. Therefore, I know that the addition is allowed. So we're also supplying the previous account state, the new transaction, and the salt. Those are all our private inputs, and we need this this previous account state, because ultimately that's what allows us to do everything. But because it's a private input, the advantage here is like it remains zero knowledge. And the way we do this is we just have, we can start here. We have our previous proof hash. So we're basically verifying here with the previous proof hash. We're looking at the previous proof, right? So that's the previous proof that was supplied by the user. And then we're taking out the T account hash, and then we're basically recalculating with this salt what the value should have been, assuming that everything was correct. And then given, the salt, and then, the name of the account, and basically like what the previous account state was. So that's here. So we're basically like recomputing the proof within the SNARK to verify that, with the previous account, or that the previous proof and the supplied value are correct. And the reason we need to do that is because if we didn't do this, this part of the function, then we can supply any value here, and then this add function would then add to anything. So basically I could supply something false, even though you're still validating the proof. It's like, okay, fine, you validated the proof, but you're still just going to like add it to any arbitrary value. Therefore, you're going to end up with a false result. So this constraint basically makes sure that whatever the user is trying to add to is a valid mechanism for where they're trying to add. And then here is where the actual addition occurs. Pretty simply, we're just adding it, and then we're just going to say like, okay, was the hash that you then supplied, is it valid? So is the value here valid based off of what the proof is and what the transaction is, and all these things? Is it valid? And then if it is, then we have validity. Therefore, we're allowed to add and construct a new proof of the addition. And then here is a check balance function. I sort of wrote a to-do here because I think I need to construct a proof of a proof here, because the issue right now is if anyone wants to check the balance, you need to give them the salt, and then once you give up the salt, it's no longer zero knowledge, because the salt is anyone can use it. So kind of like, I think ideally, I would say like, I would need some mechanism to say, okay, I ran this check balance with the previous account state, and basically like be able to use this as a public input for running this function. Therefore, you can just show them what the validity of this state without needing to reveal the salt, and that it remains zero knowledge. But basically, all this is doing right now is it's just recomputing the hash with the with the state, and then if it's true, then basically you get validity that the balance of this is true. Yeah, so that's pretty much where this is at. I have a few branches which are work in progress, but this is complete. The things that need to be done are the vectorization, but I kind of have like a broken implementation of it where I was trying to prove proofs, but because Kimchi only lets me do 2 inputs, my option there is either to do aggregation or just to keep it as fields, or just like as T accounts rather than like a proof of T accounts. I'm leaning towards like doing aggregation, even though the implementation is a little bit more challenging, just because I think you get good composability with that, which will be interesting, where you can like start doing like DAO stuff where individuals have their own T accounts, and then you can have a DAO which is like a T accounts of proofs of T accounts, and you can extend it out like that. And then so that's sort of the blocker for me, and that's where I'm like wanting to really like go in and kind of make this generic, rather than implementing it just like a direct implementation, because with the generics, it becomes like, it's almost like a DSL, right? And it becomes like an accounting DSL, and then it becomes much easier for users to build stuff with. Because as it is right now, like if anyone wants to build something, they'd have to like basically reconstruct what this is. That's sort of where it's at the moment. And then in terms of like in real life stuff, I have like pretty good feedback from some VCs that are interested in this. And actually, like I think the first project we're trying to implement is we're looking at acquiring some property in a town called Magnolia, Arkansas, because there's about to be a boom there in terms of like lithium mining. So we're looking at some property and basically going to tokenize it, and then all of the off-chain state, we're going to basically like bank account data and all this stuff. It's not going to be super secure, like in terms of like we're just going to query the API and add it to the account, and but it'll be a good like first step, like good MVP. So it's kind of where the development's at the moment.
Awesome, thank you. I was actually going to ask, because you did mention before that you were doing something in Arkansas. So I was like, that was gonna be my follow-up question if you answered it. So awesome. But thank you so much, Arjun. Like it was really cool to witness this and like tap into what you're working on. Does anyone have any questions, call outs, praise?
I think it's really interesting. In my head the whole time I've been thinking more kind of like traditional financial applications being brought. Just how you started off, like kind of like not just being a bridge to traditional finance, but actually just like rewriting institutions on and off chain.
Yeah.
But I did not even like jump to about other types of real world assets outside of primarily just financial assets. I think at the end now my brain is starting to explode a little bit with kind of the implications of the accounting side of this.
This is why the VCs are excited as well, because I don't think so. I remember reading I think Alessandro from Starkware, he had a blog post, and the way that he described it was the way our systems work currently is delegated authority, meaning we delegate some authority to a group of people, and then we trust what they say. And ultimately what these SNARKs do is they move our systems from delegated authority to computational integrity, meaning we no longer have to trust that this group of people are saying what is valid. We can just verify the proof. And then obviously this has massive implications about MEV, right? Like we don't talk about MEV in TradFi, but MEV, like TradFi is all MEV, right? That's just like how they function. Like that's how they exist. Like that's what Citadel's business is, right? Is MEV. Yeah. So it's like, okay. So like, we're here in crypto and we try and like propose we're building a new financial system or we're building all this new infrastructure, but we just haven't built anything that's actually better than what already exists. And we haven't made that use case of like, other than like, like journeymen and like explorers trying to explore this space. But I think here, once we can encode like traditional finance, like just like traditional.
Yes. For those watching the recording, Raphael and Mate have combined two Cohort 1 independent proposals into a one new entity called Protokit, and they're going to take us through. I think I'll defer to you guys on what the best way to go about this is in terms of covering kind of the merge and what you've delivered. So over to you.
Sure. Hi everyone. My name is Maki. I'm one of the founding engineers of Protokit. So before I explain to you what Protokit actually is, I want to start by setting up bit of a context. As we already mentioned, Protokit is a result of merging two Cohort 1 projects, namely York and zkFS. So let's get right into it. So Protokit is a protocol development framework for privacy-enabled application chains. So basically, it's a framework that allows you to build blockchains using Starkey.js. So moving on. So before I get into talking about what Protokit actually is on its own, I first want to talk about what options you currently have if you want to build a Mina. More especially, how does it look like if you want to build smart contracts in Mina? So I want to talk about the design goals of zkApps and all the challenges that come from the design of zkApps. So the three main things that I could think of when building this pitch deck was that zkApps are privacy enabled. That means that you get like off-chain computation, therefore any inputs into your smart contract code is private because it stays on your machine. Secondly, it's lightweight. So it's meant to be executed off-chain, and that allows the L1 chain to be as lightweight as possible because it doesn't have to bother itself with actually executing the smart contract code. Whilst the third point, which I already mentioned twice, is that zkApps are executed off-chain. So the computation happens on your client, not on the chain itself. So those are like the design goals that we believe all the labs went through when they designed zkApps and smart contracts on the L1. But we also think that there are some challenges that people will face when they will start using zkApps. So let's talk about perceived challenges and side effects of the design of privacy-enabled zkApps, and what are some common issues that developers struggle with. So again, top three things I would say is the limited on-chain storage that you have when you write your smart contract. So it means that any smart contract that you write on Mina can only store about 8 fields worth of storage, which is around 255 or 56 bytes or bits of storage. Doesn't matter, it's not enough one way or another. Second problem or side effect of the privacy-enabled off-chain executed design is that we have account update complexity. So the smart contracts behind the scenes issue account updates that are authorized by proofs, and the proofs are generated by running your smart contract code. And these account updates can get quite complex. The third problem is that you have limited building concurrency. So since all of the transactions are executed off-chain, it means that if multiple clients want to interact with the same smart contract, they are not aware of each other. And therefore, if they want to perform any state updates, they essentially invalidate one another, which leads to difficulties when it comes to designing smart contracts easily. In order to address the concurrency issues, there are some built-in tools in Starkey.js, but there's currently no recursive rollup tool except the built-in reducer API. So what did we do as part of Cohort 1 or before Cohort 1 to address these challenges with building zkApps? So each of us individually, we have built two separate projects. One was zkFS and the second one was York. zkFS aimed to solve the off-chain storage issue, which meant that you didn't have to rely on the storage of data on-chain, but you could use Merkle trees and Merkle witnesses to prove belonging of data to your smart contract and to use this arbitrary data in your off-chain execution. This solution, like I would like to say that I solved the off-chain storage problem, but I didn't solve the concurrency issues in any way. So zkFS on its own, while it helped zk developers in a certain way, it also left them hanging with a set of different challenges that they had to solve themselves and that were not that easy to solve on their own. The second project, built by my colleague Rafa, was called York. York was basically aiming to be an isomorphic L2 to the existing L1, while fixing some of the existing issues with block times or speed-related issues. If you use York, you would be able to address also some of the urgent storage capabilities because you could use custom account update circuits etc., etc., etc. But the original design of New York also kept the execution of chain, so you would still be left with the concurrency issue. So both of these issues try to tackle some of these problems in their own way. One of these projects try to tackle these issues in their own way. But none of them actually tackled the biggest issue of them, which was concurrency or sequential state updates. So that was kind of like the context to what the original solutions were supposed to do and what they were supposed to achieve. So yeah, let's move on. So where do these existing solutions fall short? So as I've already discussed, zkApp has only solved the storage issue, while Node focused on speeding up or customizing the account update zkApp stack while keeping the execution off-chain. So the question is there a better approach to addressing these challenges? And after talking to Raphael quite extensively at the beginning of Cohort 1, we basically came up with a better way to address all of the issues and provide additional and extra features on top of what zkApp as a Node couldn't do on their own. So I would like to introduce you guys to Protokit. Protokit is a protocol development framework for privacy-enabled application chains. It combines all the good parts of the Node design, zkFS design, and zkApp design. It allows you to be concurrent. It allows you to have, let's say, unlimited on-chain state. Plus, it maintains the privacy aspects of zkApps. So, what can you build in Protokit? So, you can use Protokit to build zk chains, L2s, or rollups. zk chain or L2 or rollup is a zkApp, let's say, that is quite a bit more sophisticated than a standard smart contract. It still gets executed de facto off-chain, which we can see on the diagram here. So you have an operator that runs the zk chain. People send transactions to the zk chain operator. The operator runs a sequencer and is responsible for executing all the transactions through your zk chain front-end logic, producing blocks. And then once you have an L2 block, the L2 block travels to the L1 to a Protokit L1 zkApp for finality. So Protokit is a framework or a JavaScript library that allows you to build an L2 chain using Cypher.js and roll it up into the Mina L1. So it's like the TLDR. Now you're probably asking, like, what kind of building features does Protokit provide, right? We've already discussed issues with zkApps. We discussed some of the potential solutions. And now we have Protokit that supposedly combines all of the good parts into one solution. So we designed Protokit in order to address the challenges that we have faced while building zkApps. But not only that, it also solves all of the pain points of the previous solutions. So with Protokit, if you write the zk chain using Protokit, you will get the following features. So you'll get unlimited on-chain storage, as long as it fits into one of our market trees, which is so large that before you fill it with data, you'll probably run out of memory anyway. So that's a claim, right? Unlimited on-chain storage. Plus, we offer a custom zkVM execution environment that is different from the already known account updates. We have built our zkVM around much simpler state transitions, which allow us to do, again, built-in sequencing and concurrency support on the side of the sequencer. So the main paradigm shift again here is that the zkApps remove the execution from a node to the client. Like on Ethereum, you run transactions on a node. With zkApps, you run transactions on the client. I mean, we already know that this creates concurrency issues. So to solve the concurrency issues, we are moving the transactions back from the client to the node or to the sequencer. But unlike in Ethereum, the sequencer has no room to lie about the execution of the transactions thanks to the protocol and the zkVM that we have designed. So how is all of this possible? So I've already mentioned we have our own custom zkVM, which brings an experience to zk chain developers while still maintaining or enabling the privacy features that we love from zkApps. So enough talking. I didn't prepare any more slides. So the only thing that's left here is to show you guys a demo. But before I do that, I'm going to ask Will, how are we looking with the time?
You have about 30 minutes left, so we have extra time. So
30 minutes left or 30?
3-0.
3-0. Okay. All right. Cool. So,
but sorry, just to interrupt, but we do want to probably say like 10 minutes for questions. I mean, it's, but yeah, yeah, go for it.
Okay. All right. So that was the presentation. Let's move to the editor for the demo. So, what I'm going to show you is what we call the Protokit starter kit. Basically, it's a way for you to clone a repo and get started building your own Protokit zk chain. So, getting started with it is very, very simple. You just have to clone the starter kit. So, we're going to use the following command. And clone the starter kit into a demo repository. So we move to demo, we open up our editor, and here we are. So what the demo kit contains is a configured TypeScript environment with all the libraries from Protokit pre-installed. And it also contains an example application chain with very, very simple balance transfers features built in. So the first thing you have to do is to install the dependencies. Once you have done that, you can run the tests. But we will not do that. We will instead delete all of the files that came with the starter kit. And I will walk you through implementing all the features that come with the starter kit from scratch. So I'm just going to go ahead and delete those two files. So if you want to build a Protokit chain, you have to understand that it consists of 3 features. So first you have the runtime, which contains all of the business logic. Then you have the protocol, or the zkVM, which handles all the block production, proving or applying the state transitions created from your runtime, etc. Then you have the sequencer, which is responsible for orchestrating your runtime and your protocol into blocks and submitting them to the O1. So the first thing that I would like to show you is how to write a balances runtime module, which is like a balances smart contract that allows you to forcefully set a balance for a user. So to do that, I'm going to create a new file called balances.ps, and I'm going to start implementing my business logic here. So I hope you can see this. If not, let me know and I can zoom in. So one of the first features that we want our balances module to have is to have control over the circulating or the total supply. So we're going to create a config that tells us what the max supply or the total supply should be. So let's do that by defining an interface. And we know that the total supply should be a unit 64, which is a building starter type. Then, in order to define a runtime module, we have to define a typescript class that is decorated using our special decorator. So let's define a class called balances, which extends runtime module. And the runtime module is configured using the balances config. We cannot forget the runtime module decorator. Otherwise, Protokit wouldn't know how to handle the class. So we've defined our config, and we've defined the first runtime module, which will hold all of the business logic for our application chain. The next thing we have to define, so we want to build a function that sets balance for a user and with a certain amount. We just write a function like this, and we decorate it with a runtime method decorator. The next thing we want our balance module to do is to store balances for every user, plus to store the circulating supply. So let's start with the circulating supply. We will define a state, which will be a property of the balances class, and we will call it circulating supply. And the value for the property will be state from Protokit, from Snarky. And the type that will be stored there will be again unit 64 for the supply. So that's the API. It's very, very similar to what Psyche.js offers for smart contracts. Also, back to this, we believe that transitioning from zk development to zkChain development should be relatively straightforward, and there should be little to no learning curve as well. So we have one piece of state for storing the circulating supply, and we need another piece of state for storing the balances. So instead of state, we will use a different primitive called the state map, which allows us to store data in a key value format. So from the key will be a public key, the balance will be 864, and just initiate it like this. So next step would be to write the business logic for set balance. So the question is, what do we exactly want set balance to do, right? So we said that we want set balance to set a balance for a user to a certain amount. So that would be pretty straightforward with the building APIs. So we have the balances stored, and we need to set for an address and a certain amount, right? That's pretty much all code we have to do in order just to set a balance for the user inside of the state map or the key value store. So with this business logic, we cannot forget to actually export a class, otherwise we won't be able to use it. We can move forward to writing a test. It shows us how can we spin up a testing chain that runs the balances class as part of the runtime, and how to invoke the setBalance method from a user-signed transaction in order to change the state of the outer chain. So for that, we will write a simple just test like this. And let's write the test. So describe balances. It should showcase Protokit. And we'll go ahead with the missing function like this. All right. So we need to create the app chain first, right? So let's do that. We will use the built-in testing primitives from Protokit called the testing app chain, and we'll create an app chain from a runtime. So the runtime consists of runtime modules, and the only module we will use is balances, and we cannot forget to import it. There we go. So we have module balances, and we also have to pass the config for it. And we know that the config is total supply, which has to be a unit 64. And let's say that the total supply is 10,000. So we have an app chain. Now we have to run it, and we have to send a transaction to it to see how it behaves. So the first thing we have to do is start the app chain. And then we have to send a transaction to it. In order to send a transaction, we need to have a sender account. So let's create a sender account for ourselves. So Alice, private key, will be private key random. And then Alice is the same key, but it is a public key. Now, we also have to let the app chain know for the testing purposes which key we will be using as a signer. So we can do it in the following way. Set signer, Alice, private key. So the testing app chain that you see right now is using what we call the in-memory signer. So therefore, we use an in-memory private key for testing purposes. In reality, if you actually were writing the UI for this and you were running an app chain on the client side or the browser, you wouldn't use the in-memory signer anymore. You would use the hour signer, which would let you sign Protokit transactions using the hour. So all of this is possible because Protokit is built using Psyche.js primitives. And what our.js actually offers is a function called sign fields. So our transaction is translated into fields, signed, and then sent to the sequencer. So it makes us compatible with our out of the box as well. All right, so we have created a key pair for us to send our transaction. We've set the signer for the in-memory signer, and we've started the transaction. Now it's time to send, we've started the action, now it's time to send the transaction. So let's define a transaction. Let's go to transaction 1, and we will call appchain.transaction, specify the sender, and then provide a callback of the runtime module or the runtime method we want to call. So we know that we have created an app chain with the balances module, and we want to call set balance on the balances module. It means we have to retrieve the balances module first. So we'll go to the app chain, we'll look at the runtime, and we will resolve the balances module. As you can see, it's auto-completed in TypeScript for you right away. So we really believe that typing this strongly makes it a much easier developer experience than if you have strong types. So now we have the balances module resolved, which means that the class has been turned into an instance, the config has been passed into it, and we are now ready to call the setBalance method. So balance is setBalance. We are setting it for a user. The user is Alice, and the amount is, let's say, 8,000, right? So we have 10,000 as the limit of the total supply, which we are not checking yet, and we are setting the balance for Alice in this call. So second, you have to sign the transaction, and then you have to send it. So what happens here is that when you call the set balance of the balances module, behind the scenes, the transaction API knows which method you are calling, which module you are calling, which parameters you are calling, turns it into a transaction. The transaction object then gets signed by the configured signer, which is in our case the in-memory signer. So it means that the result of this is signed by the signer, which is Alice. And then we have to send the transaction. And what happens in this case, the testing app chain has an in-memory version of the sequencer running in an in-memory private mempool. And the transaction API sends the signed transaction to the mempool and the sequencer running in your test. So we now have prepared the transaction, we have sent it. The last thing that's remaining is to produce a block. So we'll use the helpers that we have available, and we will produce a block. And we can also return it like this with block 1. So couple of things that we want to check now that we have sent the transaction. We want to check if the transaction status was successful. And secondly, we want to check if the balance for Alice has changed as we have basically expected. Let's check the transaction status first. So we'll write an expect statement where we will check if the block includes transactions, and the first transaction, so we only sent a single one, has a status, and we expect the status to be true. If the status is true, then we know that the transaction was successful. And I think it's the time to actually run the test before I continue writing any more code, because then debugging it will be a lot of fun. So we already installed dependencies, and we can run the test. So let's do it. It takes some time, like 10 to 15 seconds to actually run the test, even though we are not doing any proving. We suspect that it's probably the fault of the StarkGL bindings that make this quite a bit slow. So, but we've heard that someone is already working on improving this. All right, so we have executed the following test, which means we created the app chain, we started it, we created a key pair, set a key as a signer, and we executed the transaction to the balances module, calling the setBalance method, setting the balance for Alice for a certain amount. We sign and send the transaction, we produce the block, and we checked in the test that the status of the first transaction included in the block was successful. So we are basically getting there. Now the next step would be to check if the state for Alice in the balances module has actually changed. So to do that, you can use what we call the query API, and it's relatively straightforward. So let's check balance Alice. You have to await app chain query balances, then the balances property that we have, and then get, and we have to provide a public key that we are getting it from the key value store, and that's Alice. So the last step is to expect that balance Alice to begin. I'm sorry. We expect the balance to be what? We expect it to be 1,000, right? Because we set the balance to 1,000 here. So we can save it, and we can run the test again, and it should work. There we go. It worked. There's quite a bit of things happening behind the scenes. We put a lot of effort into making sure that all of the complexity is abstracted away from the developer, and that they have to do the least amount of work necessary to ship their features and their products on top of our framework and on top of our stack. This doesn't mean that you're basically like weatherlocking yourself into all the code that's going on behind the scenes. Everything that we wrote is completely modular. So any of the concepts or architectural pieces that I have mentioned previously can be replaced rather easily. But we won't really go there just for the sake of the demo and the purposes here. So, so yeah, that's pretty much it. Depending on the time, I could continue building in other features, building in like a transfer, etc. Or we could talk a bit more about what actually happens behind the scenes. How does the zkVM work? How do we actually produce and prove blocks? How do we ensure that no transactions are left out from the transaction bundles? So there's quite a lot of things that we could be going through here. So I think it's better that we move to questions, and then I will clarify depending on the questions that people might have. What do you think, Will?
Yeah, well, I think maybe let's pause. I think given availability, it looks like it's just Kobe and Yasin and Janae. So I've seen the demo a few times. Maybe let's pause for questions and then we can go from there. Sure. I don't know if any of you three have any questions or feedback.
One thing that I would like to ask, like, I'm assuming the video will be watched then by the Electors, right?
Yes, that's right.
Yeah, so we were kind of planning with Rafael that he will present a little bit more about the architecture behind the scenes, how does the zkVM work, how does the sequencer work, what do the circuits look like, showcase the provers that we wrote, and all these other things. So I don't know how much time we have left, but if there will be no questions, which I'm hoping there will be some, maybe we can then let Rafael to also deep dive into these other things.
Okay, yeah, that's, I mean, I think we've got about 10 minutes left, but maybe first, Kobe, do you have any questions or feedback?
Put me on the spot. Obviously, this is really exciting, and it's a lot to take in a demo. So I think I would be interested in sort of reading through some documentation and getting to know more of the advanced use cases. I guess I do have one question off the bat, which is, are any of your demos, do you have a demo that's like something that is really not possible to do in Snarky.js vanilla that you've solved like a key pain point? Or is it something that you know that it works and you're waiting for someone to use it to solve a problem like that?
Yeah, so I think the main point, which I was hoping to bring across during the presentation, was that there's no way out of the box with Snarky.js to have sequenceable state transitions, right? You can use the reducer API, but you will run into quite a lot of issues. You have the circuit size limitations. The reducer API also has its own like design limitations, like you can get deadlocked if there's too many actions to process, etc. So we wrote a series of circuits that interact with each other recursively. One of them proves the execution of your runtime business logic. That's the runtime code that you saw here. Then the runtime code outputs state transitions. Then we have a separate circuit that applies the state transitions to the local tree state plus a database. And then we have a block which takes both of these things, puts them together recursively, merges them, then merges with other blocks to create a single block out of all the transactions that have been sent. Plus, it checks that the no transaction was left out, following the principles of sequence state, and then submits that L1 block to the L1. Of course, you can do many interesting things that you wouldn't be able to do even on a smart contract platform like Ethereum. You can reorder transactions. You can prove that you have reordered them in a certain way. So yeah, but that's like the benefit of the app chain approach over a general purpose smart contract.
Makes sense. And maybe Do you want? I mean, I know it's not included in the scope of Cohort 1, but talking about like some of the biggest, like, do you want to go into detail around what your kind of like vision for what the biggest like next applications could be?
Sure. So we built the tooling. Next, we're going to focus on continuing improving the tooling. We have to write the products. We have to write a lot of developer-faced tooling, like we have to write a custom blog explorer. We want to have a better world integration. Then we want to work on interoperability between these chains. We have to finish writing the online contract so we can bridge tokens in and out of these app chains. So all of these things we have designed in the early stages of development, but given the time constraints, we haven't built them yet, and we're looking forward to building them in the next cohorts or in separate grants. So yeah, I think like the goal for us would be to talk to all the cohort 2 projects that end up getting funded or start building even if they're not funded. Explain to them the kind of challenges that they will have to face when they try to build big smart contracts, and hopefully convince them that building an application chain is ideal for their product and for the use case. Hopefully using the tools that we have built.
The Snarky.js issues are something you have to experience firsthand. You might have better luck talking to the Cohort 1 people.
Yeah, but like that's a different discussion that I don't want to really have here. But yeah, like so another way to look at it is like, okay, once we run into these issues, solution to kind of tackle them is already here, and they can migrate to.
Makes sense. Makes sense. Okay, well, I think that from a demo perspective and also like delivering on the kind of different features that were across both projects, I think you've explained it nicely.
Yeah, thanks.
I'm wondering, so we have like 7 minutes right now, but if it's going to take longer, it might just be easier to just record, like screen record a separate video and just send that in, and then we can include that as part of the file that we share, if that works. And then that way.
What do you think, Rahel?
Yeah, that works. That works.
Or if you want to do it in the next 6 minutes, we can try to do that. But
I mean, yeah, there's no rush. I think like all the content that we presented is a lot to take in for now. I think like getting too technical probably will only lead to much confusion. So I think that's okay.
Okay. Okay.
Yeah. By the way, Kobe or if anyone else wants to like try it out, it's already open source, so you can run the commands that I have run myself. I can send it to you on Discord again, and you can already start building your own app chain today if you want to, and start figuring out like with the logic how it works.
Is it deployable yet? Or could I only run it locally with tests?
So you can only run it now in memory, so locally. We're working on GraphQL resolvers for the mempool and for the state fetching, and at that point you can consider it deployable, because the only thing that is missing from making this deployable is to be able to submit the transaction to the existing mempool over GraphQL, not just in memory, plus to read the state over GraphQL, not just in memory. So those are two very small steps from making this actually deployable.
Okay.
Cool.
Yeah. I see it. You're good to go.
Okay, great. Okay. So my project is RankProof. Essentially, it's a platform for certifying martial artists ranks across many disciplines. And essentially, you can share your rank with other folks or promote your students and so on. So I was going to do a quick walkthrough with some live demos and videos intermixed, just because the transactions would take a bit long to finish. So just gonna kind of mix live and video. We're going to talk a little bit about code, and I'm sure if you all wanted to talk about code, I saw one document mention code, so if we have time, we could look at just some of the major components as well. one of the milestones would have been user feedback, which we'll dive into, and then some challenges again if we have time. Let me just get into it. So for the walkthrough, I'm just going to jump right into it. Here we are. Okay, so this is RankProof. You're kind of greeted by two guys on the right there. Those are both my instructors. They're actually black belts at the moment. They've been doing martial arts for over 30 years, and in varying disciplines like Brazilian Jiu-Jitsu, karate, judo, you know, even local martial arts like Kalinda, which is a stick fighting in Trinidad and Tobago. So, you know, their use case is kind of what RankProof is about, being able to track your certifications across multiple martial arts. So, as well, they have some marketing stuff, but I mean, this is just fluff for the moment. It's not real at the moment. So I'm just going to go ahead and launch the app. Doing that. This is basically just loading resources in the background. I didn't change that much from what the tutorials kind of did. So this guy that we pretending to be right now is a new guy, a new martial artist. Just actually thinking in the wrong screen. Hold on. I have millions of tabs, so as you can see. So let's see, hopefully. So I wanted to start with essentially connecting your wallet to the application. And then just kind of taking a look around the portal itself. So you can see it pops up your Oro wallet. RankProof wants to use your Mina wallet like your identity, similar to how you would like Gmail or Facebook. You sign into various accounts. So instead of relying on those third-party tech companies, we're gonna, you know, own our own data and essentially approve our connection to RankProof ourselves. So once everything in the background is loaded, don't worry. So let's give it a moment. It's loading. I guess we could ignore that and just come here. So once you finish loading, you're presented with a dashboard. The dashboard basically made up of several areas that can help you track your martial arts journey over time. So basically you have this heading here where, you know, you have your profile, which is basically, again, your identity. A notifications section. This is not live yet. This is just fluff, I guess. To see, you know, various notifications within the application. This section is a alerts area where you we'll see this a bit later, which kind of gives feedback as we go through the app and you do different actions. You'll get some updates from the screen. As well as this is your profile. Essentially, kind of shows all the martial arts that you practice. The ones in gold kind of denote martial arts that you've been verified by an instructor, as well as this one. I just started this, so it's not verified yet, so nobody knows, you know, if I actually have this belt or not. But the ones in gold kind of denote that. And again, this lineage area, which we will look at a little bit, which is essentially tracking like your family tree of martial arts, you know, going back as far as we can. And then this section here kind of lays out all the actions you could perform within RankProof. So you can add a martial art, promote students, prove your rank. You can view your address for sharing purposes. Below here, again, not implemented yet, but it would be cool to have some stats of registered users, how many people, how many black belts we have, and so on. So this is basically the dashboard, and I'll kind of get into like a little journey of a martial artist now. If you want, you guys could ask questions during, no problem. So I'm just gonna jump ahead to a new student. So this guy, new student, reached his gym. He signed up for the trial class. He loves it. Brazilian Jiu-Jitsu is the best thing in the world. That's what I think as well. And he wants to sign up. So somebody tell him, hey, scan the code on the wall and sign up for RankProof. So let me see if you can see. Oh, let me take off. I'm not sure how to take off the background, but then. So have a QR code that we put on the wall, basically. I want to get a stick up on this wall, but it's printed and work. So here we are. So I want to continue. So I'm just going to turn off my camera for a moment because we're going to do some scanning. So the browser needs to take ownership of the camera. Essentially, as I was saying, you're going to scan the code on the wall because somebody say, hey, join RankProof. And our instructor probably would have printed it from his RankProof and stick it up on the wall. So as a new student here, you can see I don't have any martial arts yet. And the only actions I could perform are to view my own address as well as add. So I'm going to click on add. Going to select the martial art of choice. Well, I'm a white belt. Then we'll do that. Specifically, it's up there, but there we go. Scan. So you can see me high. So I'll just show you so it wouldn't scan until so. So essentially, you're presented with the scanning interface, and essentially, you pretend this is me on my mobile phone, and I just scan the QR code on the wall, and I'm gonna click Add Martial Arts here. And again, this is the area on top we mentioned, which is it is gonna give you some feedback while you're waiting for various stuff to happen in the background. So with that being said, so what I did, I actually working on the local blockchain, so proofs and stuff wouldn't be submitted. So I'm just going to jump to the video. Hopefully this works. Yeah, so you all see the video clear, great. So again, it logs and it does stuff at the top. Next, you'll see, well, again, more info proven, and I'm going to send any transaction to Mina. Pop up your Oro wallet, and you can prove the transaction. Once that's done, RankProof will essentially say, hey, transaction is complete, well submitted rather. And you could essentially jump over to see the transaction if you want to go about your business. So you see here it's pending. And once that's confirmed, you can essentially head on over back to the RankProof application. Now we log on here, yeah. And we're gonna essentially now see our rank get added here. As well as a new action I have available, which is to prove my rank. Let me jump back over that side. So once you add your martial art, you might, tell the instructor if you could ask it, if you could verify on some random chat. It's not part of my app, it's just whatever. Put it back. So he's asking if you could verify me. The instructor said, sure, just send me your address from Ram. Yeah, just click on my address and you copy the address It's not necessarily as user-friendly, but I just wanted to have multiple ways to be able to interact with the address itself. So this is an instructor login, so I can switch back. I can switch over to the live tab of this guy. So this is your instructor. I'm a black belt in Brazilian Jiu-Jitsu, certified, and a brown belt, not yet certified. So I'm going to copy your address from the chat, and I'm going to click on promote. And I guess I was supposed to release it, but here we are. So essentially, pasting in the address, you choose the martial art, the rank, and then you can click promote. And again, same thing happening, stuff happening in the background, and you get alerted to what's going on. Again, I'll jump back to the video. I hope the jumping back and forth with the video is clear. Again, this video, I didn't have it on mobile, but this is an instructor. Click promote, and if you can see, I know the video is not clear, but he's sending the transaction for promotion, and he's going to confirm it. Same thing, you could do the transaction on while or move on. Once that updates, see confirmation here, and again, this stuff happening on Berkeley. So the instructor sends back a message here, you're verified, and the student logs in, and you'll be like, again, you see your golden rank, or I'm a blue belt. You can now go ahead and view your lineage. So the guy above, this is essentially just a family tree of, the first martial artist. So this guy is probably Helio Gracie, which is the founder of Brazilian Jiu-Jitsu, and then have my instructor, the guy who just promoted me. And then you can see me over here underneath him. So once I get verified, I get added to this lineage tree. And we'll look a little bit more. I will just probably have a larger tree so you can kind of get a sense of, well, what it looks like in the context of, more students. Some stuff will have to change if we go to very large martial arts, because you have to be able to search and scroll and probably dive straight to notes and stuff like that. So that is getting verified. I think I was supposed to mention that some of these things were part of milestones. So the scanning and sharing of the QR codes would have been part of my milestone 5. And then creating your own rank in a martial art would have been part of milestone 2. And this is milestone 4, which is visualizing your lineage, which is, almost most of the milestones as it goes. So the next thing we want to do is promote our student. So just jump back here and kill this guy. So I guess the scenario is the new student that joined and tracked his lineage and RankProof, finally, I guess, sorry, I have a terrible saying, he finally earns his stripe. As I read it, I hate it. But it's time for him to get promoted. And again, this is following in milestone 3, which is to promote your student. So I'm logged in as a black belt instructor, and I'm at the gym, and I know that this guy deserves to get promoted. So I'll tell him, hey, pull out the phone, and I'll click promote. And let me see, open up my my phone, and I'll scan his address. So again, I'll try to show where it wouldn't thing here, but this is RankProof. and essentially scan his QR code, and now I can go ahead and promote him to black belt. And I'll also choose the notification. This notification, again, not implemented yet. However, all the actions that happen within the smart contract do emit events that can be read. So the events are being written now, but I'm not using them at the moment. So we'll go ahead and click promote. And again, I'll jump back to some video. Same kind of thing, black belt, proven, submitting. And again, once that's complete, you're gonna look for a transaction or not. Log back in as a black belt. Now you can see I have the golden rank of black belt. Again, sorry if you can't make it out. I'm not a video editor, clearly. But you can see you have multiple actions now. Now you have your own student section. You can promote or revoke people or prove their rank. So I'll just switch over to probably the desktop view here. Let's get it. So this is a black belt. So he has all these actions here. So now that you are black belt, people, don't believe it. So again, same thing. You're gonna prove your rank to them by same thing. You scan another QR code, their address, basically, and essentially say, "Hey, I'm a martial artist." What this does at the moment, it checks your rank and writes an event or emits an event to on Mina. So that's basically proving your rank. One more thing, so I didn't think I showed this, but you could essentially share your address like this. This is what I was doing on my phone, and I just want to show probably how like a larger. Let me see this guy. So in judo, I'm a black belt, and I have all these students. My students have 11 students, and so on. So I can kind of zoom in. Again, when it gets big, the metaphor will have to change a bit. Probably more searching and navigating to node, but I like being able to look at it as a whole and then zoom in further. So that is basically it for the demo of the application. Again, when we're talking, speaking about milestones, I would have had them somewhere, but essentially we creating our, I had it open somewhere, but the wallet login is we logging in with the Oro wallet. We have a web portal that supports martial artists. We can create and promote students as milestones 2 and 3. We can visualize our martial arts again. And I think 6 would have been the user feedback, which we will get into now. So it's 3:19. I'm just going to skip ahead to probably a little bit on the feedback, and then I can show code if it's necessary. I don't think it is, but I guess you guys could tell me. So any questions on this right for now?
Yeah, I actually wanted to know, my question was going to be about the user feedback and what people were saying about this. So if you could tap into it a bit, I would appreciate it.
Yeah, I'm going to jump in there. Okay. So I'll circle back if there's time. So what did we do for user feedback? So what I did, I essentially had two methodologies. One was a survey that I sent out to a community of martial artists. I mean, not huge community, but the feedback was very good from them. as well, I had a focus group, essentially a demo in person, to get some feedback. To get some feedback from them on, well, one, does it make sense? And is it something that they're interested in, as well as to get feedback of, well, what could be better or what could be done differently, and to kind of validate the use case. So in terms of the results of this survey, again, high percentage of people practice multiple martial arts. High percentage want to manage the rank digitally. A lot of them also interested in lineage and rank with validity. So being able to prove that, yes, I am who I say I am, and you are who you say you are. I think I added some blockchain type questions, which would have been, knowledge about blockchains, zero knowledge proofs, and self-sovereign identity. Lots of folks not really familiar with those things, especially the last two, zero knowledge proofs and self-sovereign identity. But it was again useful to produce some ideas around feasibility. I do have I think in the document that I submitted, I would have included some of the responses on excuse me, just like some breakdown of the answers to those questions. Other than that, I did a focus group, small group at a dojo. I was supposed to do 2, but the last one was planned for Monday, which didn't work out as what I wanted. So I only had 1 focus group session. So I demoed to them the application. Funny thing that came up, was talking about the lineage tree, and I was saying, I don't know if I want to show people's names, and the project kind of focused on privacy a bit. So it was just playing with the idea. Somebody asked, well, I can't recall how it got there, but somebody asked, how can something be private and verified at the same time? That don't make any sense. So it's just something funny that happened. And for me, again, before this process, I would not have known about zero knowledge proofs to that degree. I've heard the term before, but it's very cool to actually hear somebody say the same thing I was saying a couple of months ago. Other than that, a lot of people ask for, messaging back and forth for students, as well as essentially they were talking more about like a social network for martial artists. That's not necessarily my thing, but it makes sense. That's what people want. So I can't deny that. As well as some gamification, being able to get badges and, progress towards goals. One other feedback. Of course, as well as I got validation of the use case because a lot of folks were interested in it. And I think even some guy who didn't see the demo tried to pitch me his idea for an app, which was the same thing. So yeah, it was a good set. It was good getting the feedback and getting the validation. Any questions about the feedback, Jenny?
I was entertained with some of those thoughts. I can only imagine hosting a group of people probably thinking they know more experts. But yeah, I really appreciated seeing that. And I overall, like with everything, I think it was awesome that you were able to conduct feedback and do kind of like research sessions. It kind of then dives into that area of this being like a business and trying to see what users truly desire. And I think that is like such an awesome ability that you were able to have. So I really appreciate that. And I also appreciated the fact that with your project and your proposal, you definitely went very niche. And I think that's incredible. It's like cool to go niche and then think about it in alternative ways it can expand and grow. And I think this use case can be applied to so many other things, especially in those kind of like industries where, like you mentioned in your proposal, people just walk around with certificates and less proof of who they are and what they do. So, you know, that could go for anything from like a yoga instructor to other things. So thank you. I'll push it over to anyone else if they have any questions.
Yeah.
Not much questions really from my side. I was greatly impressed actually though with what you delivered. I think that met all the milestones you mentioned, because that's amazing to see all the scanning actually fully working. Was snappy as well. Great to see the tree lineage. That's great. I also had a chance to look at your code, and it seems quite alright. So I'm glad you had a try with Snarky.js. And yeah, thanks for a graph. I definitely can take a look at the graphs for user feedback and the survey. Just a question, were there any particular things in Snarky.js that you've came across that kind of been problematic versus whatever you thought in the beginning on the when you've created the proposal?
Lots of things, I think. Lots of things. Let me see. I think I had a section on challenges. So let me see. Just to remind myself.
Sure.
So I think, well, surely the learning curve was a bit much for me, as I mentioned. Before, like the last year, I've never heard of zero knowledge proofs. Let me see. Yeah, I think so the code was a bit easy to get started with, I think, as most things. Like the code itself was easy to understand, but the developer experience was not great. Things took a long time to load. Some things didn't work. Some things didn't. And I guess I myself didn't understand certain things. So I do have like a list of kind of challenges that I faced, recorded probably on my GitHub, and it's just raw thoughts under an issue called concerns. You can look at it, but so like I tried to. My initial design was to have one smart contract, and then you can inherit from it and have multiple, like martial arts in that way. But I had issues with that deploying, but I as well as having multiple contracts within the zkApp, I was unable to fetch accounts for different ones. I was getting some exceptions and stuff like that. So I have it listed there. I will share it somehow after this process. But it's a lot of just issues that I dealt with. Some might be a knowledge gap on my part. Some might be other things as well.
No, I think that's great feedback, and I think we'll be very happy to see those notes, because I think that many people like you try to go through that and then face the same errors. And I understand your approach with trying to inherit contracts. I've seen you created multiple files trying to kind of inherit from it. I can understand that.
I apologize for the repo. It's just I was going nice, and then it went away. So I just
it always go like that.
Yeah.
But still, again, I'm really amazed at what you delivered, because it's all what you mentioned. So again, well done for that.
Okay, I appreciate it. Thanks a lot.
Awesome. Okay. Thank you again. One last moment. Does anyone else have anything they want to shout out? See.
I'll just say well done as well. And just to clarify, the list of issues, challenges that you encountered, that on your GitHub, you said?
Yeah, there's an issue called concerns. Again, I wouldn't want you to read it, because it's just, I just, as things happen, I kind of just write it down. But
no, that
but
part. Sorry. No, that's perfect. That's, I mean, raw, unfiltered is better. So
okay.
Don't worry about polishing it.
But perhaps I don't know what the process might be to share the feedback. I wouldn't want to just post some of the stuff all on the Discord. So if I could clarify my thoughts probably after this, I don't know, I could reach out to you or Yasin or something to
Yeah, please do. Either way, we're going to follow up. We're going to have like follow-up calls.
Oh, right. Okay, sure. Well, great. It'll have me time to clarify my thoughts. I can probably get in a format.
That would be great. And just to echo Carol, I think like it's really cool to just see, and Janae, it's really cool to see like a different idea come to life and use Snarky.js in the world. So it's,
I think so as Janae was saying, it's applicable in many things. It's a verifiable credential, right? But it's very, as you say, it's very niche, and it could be applied in different areas. So great. I think Yasin, you had a concern to make.
Yeah, I also want to shout out to you and on the user-driven perspective. I really like that, you went there and like tried to gather data and made a focus group research. So I just want to say, like, I mean, yeah, really good job on thinking like user-driven perspective and building mindset. So yeah, I just wanted to highlight this.
Thanks a lot.
Thank you everyone for being here. I will be talking about our project, which is called Streamlining Web3 Credentials. And well, we have a new name for the project, which is SocialCap.app. The landing page is here. You can see it here. You can go to the landing page. You have the link here. So if you want to go to the link, you can go there. Why we have renamed it? What we named it SocialCap? Because we think that credentials are the way you can formalize, that you can show your social capital, that is your relations, your knowledge, everything that has to do with how you perform or how you act on a given community. And we still are talking about streamlining Web3 credentials, because what we are trying to do is to get easy process from a community to issue and validate credentials. So that's the main concept of our project. We have a process for this, which starts with claiming, then selection, voting, issuing, and minting a credential. I will go just for the process before we go to see the app. The process starts by an applicant claiming a credential. Of course, an applicant can select a credential from a set of selected of claim types, which has been set up and defined by a community administrator. The community administration also sets up a given master plan for each claim type, each credential that the community can issue. After the applicant claims the credential, the process, the system just selects the validators, and it can select them from the validator set, from the auditor sets, or from the field community. After the validators are selected, these are anonymous validators, so neither the applicant nor the community admin know which are the validators which are going to validate a given credential or a given claim. The selected validators then enter the voting process. The voting process has a master plan defining how many positive votes does a claim need to be approved, how many minimum votes are required for a given type of credential, and other settings, which are going to see in the demo now. After that, after the voting process is finished, we will issue the credential if the validators approve it. And after that, the applicant can mint the credential to a different applicant wallets. So, for example, we are deploying it on minting it on Near, or it can be on Ethereum in the future, anywhere. So this is the main process, and now we are going to go just to the application to see it working. This is the main application. Let me change the user. I will change the user now. Okay, so as you can see, we didn't start it by logging with the wallet. We started by logging with with our mail and OTP or a code. So what Kobe was talking about in his presentation before, we took a similar approach in that we tried to use the wallet just when it is really needed. And these are two situations: when he has to pay for something or when he has to give a vote. So this is the general application. You can claim a new credential. These are the list of credentials that this community has proposed. You can join a community here. I have joined all communities here, so I have no communities to join. And then I have my issued credentials, which are credentials I already have claimed and got. These are my pending claims, which can be in different states according to the claim we are making. For example, this is waiting. This has not been paid yet. And this is a claim which has been claimed but has not entered the voting procedure yet. And then these are the communities in which I participate. I can participate as administrator. I am acting as administrator in the community, and I can register an additional community if I am an administrator of it. So, or I can just administer this community. So, for example, this community, you can see that this community we have no master plans yet. This is the general data of the community, and this is a master plan. A master plan is how you define a new credential. So what we are going to do here is add a new master plan. So you can say, well, new credential, a brief description, an image, a state, a draft, the option for the credentials, how many days for expiration, if it's revocable, how many credentials the community will issue for this type, when it starts the voting procedure, when an applicant can start to get a credential, and when it finishes, NFT metadata. These are the fees and shares that the community administrator sets for this type of credential. We are going to put to Mina, and this is what percentage of the credential will be given to the community and how much of the credential fee will be given to the validators and how much will it take the protocol. This is the evidence. We will require this credential. We have a small form editor. I will add just one, and this is the master plan. Okay. Well, that would be how one defines a given master plan. If I have this other community, I will show you two other master plans that are actively running. This is the evidence we are requiring for them. And so when you require a new credential, when you claim a new credential of a given type, for example, this one, it will ask you for the evidence that you have set up previously. Okay. So we can claim a new credential now. and then we have a new credential which is in draft state. And if we want to effectively claim this credential, we can just claim it now. And when we want to claim it, then it starts the process of paying for the credential. Okay. So this takes some time. So what we are trying to do is just using the wallet just when then we have started the transaction. We will have here in the Explorer, and we now submit it. When we submit the transaction, well, we have the credential is the claiming has been started, and so the claim will be changed to a waiting state till the voting process starts. We have seen here that I will show you the server output. You can see here that we are waiting for the credential. This is a process which is making a GraphQL query to check if the transaction is ready. And when the transaction is ready, it will start the voting procedure. Okay, so you can see it started the voting procedure here. And well, this involves a series of things, because we have when we claim a new credential, we create a new account with its own zkApp. So each credential or each claim has a particular account with a particular account ID and its own contract. So we deploy zkApp, the contract, every time we claim a new credential, and so the voting process has everything there. So this is the deployed transaction. And this is the address of the new deployed claim. Okay, so here it's still waiting till it is available. It takes some time, sometimes a lot of time. Once it took something like around 10 minutes to the zkApp to be fully available. So the voting process cannot start until this is finally available. But you can see that we can still work in the application, do everything here. Okay. And when the process is, the claim is available for the voting, then this would change to claimed, and it would afterwards claim to voting, which has started the voting process. The voting process starts when the validators are selected and they are assigned the tasks. So you can see that I have no pending tasks because I am not acting as validator, but we are going now to go to a different user, which is a user that has a pending task. They were assigned as validators. I don't know if I'm being very clear now, But you can see that this is still working. We will let it work in the server, okay? And we will now change to other user when we are going to make a vote. You see, we have changed the user, and then this user has some task assigned. We are going to complete this task, which is the voting. This is the where we generate the vote. Then the user will give a POSIT vote, for example, that submit it. We must check. I think, yeah, okay. I think I have to change the wallet. Yes. I need to change to this user because I have many users in the wallet. It's this one, because the user who is going to send the vote must be the same one that has been assigned and must be the same one who is paying for the transaction. That is checked in the contract. So we select this user. Okay. Okay. We are ready to vote. Okay. It seems I have already voted here. I will change to other user or to other. You see, this has verified that I has already voted, so I think I need to change to this one. Okay. Looks usual, more than unusual. Sorry for this. So we have sent the vote now. And we have the transaction here in the Explorer. And we are done.
Mario, you're on mute, by the way. I don't know if you're speaking.
And so this task.
I could hear him.
Oh, okay.
This task had disappeared. Okay. Sorry.
Sorry. Just disregard. Keep going. Sorry about that.
Okay. Is everything okay? So, okay, it's hearing. So, well, after the credential is, after the task is done, so I have no more, well, I have one pending task, but this task has been already done. I have voted on this one, and so, well, the voting process has already finished. So I don't know if it has finished or not. Because there are, is usually at least three people who need to vote for a credential. Well, so the credential may be in a different state now. We are going to go now to the usual, the other user who has claimed the credential. And well, you can see this credential which had asked before is now in the voting state here. And just to finish, I am going to mint the credential which is already being issued. And by clicking here, we see the credential, and we go to mint it. We are going to mint it the near. Sorry. Okay. So right now I will have my credential in my wallet. Okay. And this is the credential we have already minted. So this is mostly what I have to show you about the demo, the application. I don't know if you have some questions. I think it's okay with my time. So do you want to ask questions now? Do you want to continue and go to the code? Whatever.
Yeah, thank you, Mario. Really cool to see it come to life. Well done. Haresh has a question, which I don't know if you can see in the chat, but I'll read you the first one. It's two questions. One, can you export the claim / completed task proof and have it proved in a different zkApp?
Can you export the claim completed task proof and have it proved in a different zkApp? Yes, because just let me go to this. Let me see if this transaction has ended. Yes, it has ended. I think it's okay. Yes, what we are seeing here is the zkApp, okay, that has we have just started. So if you go to the state here, you can see that it has a minimum of 3 votes or a minimum of 2 votes and required 3 votes. This is the claim ID, and this is there has no votes yet, and this last state is the result of the. So each claim has it's its own account. So if you can get if you have the account ID, the address of this account, you can go and check that it's okay. I don't know if that answers the question, but once the credential is finished and the result is over, you can access this to well, you can query it. I don't know if that's what you mean by exporting the proof. Are you there?
Yeah, so other ZK apps, you can use it as
Yeah.
logic for writing another ZK app.
Yes, if I send you the account ID, you can query it. It's just as any other Mina account. Can you buy sell claims? Originally, really what we're thinking about is having what we call soulbound tokens in the sense that you cannot sell it because it's bounded to you, because it's a credential. Okay, so it's not the idea to sell credentials, but it can be used to other things. Yes, with slight modifications, it could have been changed. We have not done it yet, but we are thinking about credentials standard. It's like an NFT standard, but with some other restrictions, such as the validity of the credentials, because the credential can be valid for example, for a year, and it can be revocable or not. And then if we have an account which has those methods, you can check the validity of the credential by the timestamp, and you can have some method that you can revoke a credential by a proof, for example. So there are quite interesting things that can start from here, but that takes some other work, some other extra work we have not done yet. Okay.
Very interesting. I could see a world in which we evolve the zkIgnite platform to use a tool exactly like this.
Okay. What I think is that one of the objectives here is to make it very easy for a community just to define its own credentials, and for anyone in that community to claim them and be validated, etc. So I think that the application is quite straightforward in that sense. We have taken some decisions which are similar to Kobe in that. Well, I don't know if I have the time for it, but we are using. We are also using a relational data model to model the data, and each entity in the data model has its corresponding hash in a zkApp account. We have other contracts aside from the claim contracts. And we are using a storage architecture which we have a key value store, and each key value store has also an entity in the relational database. So anytime we change something in the key value store, it's indexed into the entities into the relational database, and so we use the relational database as an indexer for the application. So that's what the application go very fast. So that's the main idea. Well, this sort of stays mostly that.
Okay, I'm conscious of time and keeping us moving, but I guess just last question, Mario, is there anything else that you? Okay, I'll ask one from Carbonara. Is the front end deployed somewhere, or is it currently only on the GitHub?
It's not on GitHub yet. It's on our server, on our development machines. What we plan to deploy it to the SocialCap here. Okay. So here in the SocialCap application, you have a joint wait list, and we are planning to start receiving people just to join the application as soon as possible. But we have to do some debugging and testing yet. I cannot say the application is ready for production use yet. Okay, but we are quite near that.
Okay, I would say that I have a lot of problem, but the problem not come from like SNARKs, but it come from the library. It is like JS peer-to-peer, and people actually like operate it very like frequently. So as you see, it just happened like couple days ago, and then people change the API and everything. So the IPFS is like we prepare, but it not working as expected. So let me walk through the architecture of the project. So we try to build something like a zk database storage. It have a different kind of storage engine. Like we see here, we have IPFS storage and local storage, or even S3 storage. So people can actually choose which storage engine they want to use. And besides that, we build on top of GS, the lib peer-to-peer and Helia library. But for some reason, like D2 library is broken, and we have to switch to another plan, like using the RPC to connect to the IPFS node instead of write it on JS. And let me walk through the code. Like we have like, I will go to the result. Like right now, we write very simple example, like a piglet bank, like a small bank allow people to register with their name, and also like do some sort of transfer their balance to the other people, like transfer money to the other people. So we implement some sort of like schema. So you can actually define which field going to be indexed. So you can search it and find it in the database. Besides that, you can write some sort of very simple function to serialize or deserialize the data. Okay. So the piglets is like based on smart contract. It is SNARKs stuff, and then the rest of it we'll do very simple like transaction, like transfer from one people to the other people. And then here is the path that we handle with the zkDatabase. So we actually can like add the data into the zkDatabase. It's going to construct the Merkle tree, and also able to get the winners and allow people to perform the transaction and also prove the correctness of the data. Here is an example for transfer function. As you see here, like we just need to find the account from the database with the given name, and then we load this account from the database, and we can also get the witness of this record, and then we perform the transaction. Like everything will be handled by the Merkle tree implementation here. Like Merkle tree storage, it can be constructed with any kind of storage engine. So you can store the Merkle tree on the IPFS, or store the Merkle tree on S3 or look on your local storage. And then this Merkle tree can actually load and reconstruct from the storage. So for example, people can actually store the data on their computer or on the cloud, and then later on they can recover from the state that the Merkle tree have that shape, and continue to perform the transaction and do everything they please. So I will try to do the piglet bank demo. As you see here, it read the data from the database and also perform the calculation and also store it back. And if you see here, so here the balance of before we do the calculation, do the transfer, and they did the balance after. And if we run the sample once again, and then we can actually like have this different result here. It will continue like perform the transaction and stuff. So actually the Merkle tree have been stored in file, so it can reconstruct and continue the computation and stuff. And the data is off-chain, yeah. Here also an example, like very simple to show people how easy that we can actually like how we can actually like do the data manipulation. For example, here you can load the data and also serialize the data very easy. Okay, let me, that's it. And actually we do some optimization, so it's quite quick to write and read the record from the database. And okay, so we actually like complete the milestone for key value, and also we add some sort of like indexing, very simple index, allow people to look up the data. Besides of that, we also implement the IPFS part, but the IPFS is here, but it's broken because like right now the library that we use in the very heavy development, and the API is changing so quick, so we cannot catch up with them. Besides of that, we also implement like the zkDatabase storage and index, as you can see here. It handles metadata part and Merkle tree storage here. So it provide the data and also allow people to reconstruct the Merkle tree and also get the witness. Okay, and then we have like storage engine bay. We also have the local storage for testing and stuff. Here's the core project. There's like some sort of wrapper of the struct, like SnarkGX struct. We allow people to like support some sort of default methods. For example, here allow people to serialize the data or has the data, also do decode the data from the binary that we store on the storage. So like the user can just focus on write their own application, and they do not need to remember anything and do handle the binary data themselves. Yeah. Beside of this milestone, we also do research and also document everything here regarding to our research. And you could see we have the research about IPFS and SnarkGX that related to the zkDatabase project, and also we document like everything. We build the project, the way we build project, and we choose the technical to and make the technical decision. The parts of distributed storage also document it here. Beside of that, we focus on several things that do not include in the milestone, like the Explorer that allow people to actually like manipulate the data. For example, like people who don't have they don't have to like use the application, but they can actually like use the Explorer to look into the data and check for the proof and the Merkle tree and check for its correctness. Right now, like people decide everything regarding to this Explorer, and it have been like implementing. And we also spend some part of budget to design a new website for zkDatabase project, and also like do document, like we need to document everything so developer can learn more about project and actually understand how to use this project to speed up the development process. So right now I plan to release the first bucket, like you have the first version of zkDatabase on the release of the package, and the other people can review it. Beside of that, we also rewrite a part of module in Go, and we want to like maybe we can write a service to like a gateway for people to access the IPFS stuff, because right now whenever I use the library, like the zkApp library of IPFS, I will have the new problem, and we spend a lot of time to fix the problem that not even our file. Yeah, I think like that's all about the project right now.
Yes, please, Lawrence.
Yes.
No, sorry, I hit the wrong button. Sorry, I wasn't meant to raise my hand. Sorry.
No problem. So, Chiro, did like in terms of like learnings that you had along the way? I know you talked about the IPFS node APIs being quite hard to keep up with. But are there any other kind of like important learnings that you want to kind of share with the group around zkDatabase?
Like I think like the thing that's make me really interesting is about like the new thing that I have just seen. Some people pause it, so I capture it here. So everything just like the document of SNARKs, it's actually like very easy to understand, but then there are some sort of like some sort of demo and also assemble code. It already out of date, and it really hard to try to starting with. So the first thing that's make me like really surprised about the SNARKs is like the ability to accumulate like the witness and also composability. That's the people mentioned here. Yeah, I really love this IFC, and then I'm not sure if people then actually like put it into the production, like in the production stage. So with this feature, we can actually like make the zkDatabase much more easier for everybody to use, and also I think it will be very good proposal if it goes to the production. And also this one, I'm still I really love like this this proposal. So with this proposal, it actually makes the zk database much more cheaper to you. Like you can accumulate a lot of witness and like with in your one single transaction to the on chain. So I think it's really great.
Yep,
Yep.
that makes sense. Awesome. Fantastic. Well, I'm excited to get this in front of the community and have people start giving live feedback and working directly with it, which we can talk about at another time. Does anyone else have any questions or comments for Chiro? Yes, please, Lawrence.
Yeah, thanks. Yeah, just wondering with what you're saying about IPFS. So have you decided then not to come back to those problematic libraries? You're going to concentrate on the RPC side, or do you think maybe in the future you'll come back to those?
Right now, like I think like I spend a lot of time to figure out what's wrong with the GS library, and then whenever we fix the new problem, we will appear and also like smash up everything. So I decide maybe like if we can help people like build a gateway that actually like access into the IPFS and provide as the API, it's also good. Like for example, like people can actually like update any record or data, but the result eventually like it's still verifiable by Merkle tree commitment. So I think it do not too bad. And also I'm still believe that the IPFS is like very like good storage engine for zk database. So right now, like we spend time to fix it and also try to build the asset the IPFS via the RPC. But I hope in the future we can actually like asset the IPFS from the browser. It's much more better. It is, yeah, it will be perfect.
Well, thank you, Chiro. Round of applause for Chiro.
So, well, SOC, built by Santiago and Ignacio. We both are very happy to have the opportunity to dig in deeply into Snarky.js and find its limitations and try to go beyond them. So we're trying to build at scale and allowing developers to do so and facilitating that process. So how or what is SOC? So in essence, it's a data modeling and validation library for Snarky.js. Developers structure their data in schemas with SOC, and then SOC will do in turn will transform those schemas into structs. So for those that are not familiar with SOC, it's a TypeScript library that allows developers to model and structure the data. And then in runtime, it'll check the properties that the developer defined. So here we got an example. We'll go into a demo, but for clarification, here at the left, we can see a sub object. And we can see that we're exporting with name and we're declaring it's an object. And within it, we have two properties, an ID and a valid, in this case, date. And further into the object, we define it that the ID is a number and it has to be greater than 0. And the date, it's the date, and the maximum, if it's this a ticket for a show, it's valid up to certain date. And what SOC will do, will grab this schema and it would output this into a file. So we can see that it has its name, it's extending a struct. The constructor will initialize the variables and it will call the check function. The check function will in turn assert that it's greater than 0 and that the Unix timestamp is not greater than a certain value,
Basically, that's what it does. So why would anyone want to use this? So first off, if you're going to work with large structures, it's going to get complex, and it's very useful to have a source of truth where everyone can collaborate and check and see how the data should look, and from there you could export it and consume it throughout your application, and you'll always have everyone will have the same idea on how it should look, and there is no guessing, basically. So that's very useful in my experience as a developer, especially when working with complex data, such in medical space, for example. Also, it adds end-to-end type safety from the UI to the contract, and the developer can define where they want to have the validation either at the contract, which will be a bit complicated in terms of proof, or at the UI. It facilitates testing, maintaining, and it also adds custom errors. And lastly, I'll say it's especially it's very extensible, and there's a wide range of tools. So, for example, you could use the same schema to generate a form, and then from the same schema construct the abstract. And so from one place, you're able to, utilize the same schema throughout your application, reducing code duplication. And show the way. Okay. So briefly, we got here a meme, if you will. This is Plato's cave, and we see people seeing the light. They found TypeScript and Sock, and basically it's you have the idea plane where things are perfect, and that will be your schemas. And then when you instantiate them, those will be the shadows that people are seeing here in JavaScript. So how does it work? So first off, developers describe their object, then using, this is all in the background, basically through a CLI. We grab that object, we turn it into a JSON representation using the SOT to JSON library. With that representation, with SOT, we grab that representation using the TypeScript API, we construct the structs. And here, sorry about that. It's having some trouble with the images, but that's basically what it does. And I'll say also we extended our goal, and in the striving to allow people to construct complex things, we're trying to increase the limit we encounter on structs. So currently, structs are able to hold 8 fields. And if you want to build something more complex, it can get a bit tricky. So one way to get around that is, for example, use Merkle trees, but inspired by Solidity a little bit. What we added, it's very experimental, I'll say, but we're able to compact 64-byte numbers into one field. So that means that in the first case, you have a small number in a big field, and what we're able to do is compact. They have the smallest numbers in a big field, and then it adds auto-generates getter and setter methods to access and modify those variables. It's all written in Snarky.js, or mostly Ignacio's work. It's very intensive in proof time, so that's why it needs to be very, very heavily tested. That's why it's so experimental. So let's dive into the demo. So for those that want to check this out, the library is called SOC. It's very easy to find through Google. And here we can see the supported SOC types. So we support number, dates, and booleans for now. And in the number, you'll be minimum, max, greater than, less than equal, or greater than equal. Dates, minimum, maximum. So this is SOC, but we're going to go into a testing ground. Here we define our structs. So we're gonna follow this square object, which we've taken from the one of the tutorials, and we modified the tutorial to use sock. So the developer will describe the object first, and the second thing they'll have to do is call sock. Here we're gonna show the helper method, and we see we have the generate command. So we're gonna go yarn sock generate and help as well to see further the things we can do with it. So the generate function takes one parameter that's obligatory, that's the entity, and that's the file where we want to grab the schemas from. So we're going to go yarn sock generate, and we're going to go source schemas.js. And so we've added this output for the demo. And if we go to the top, we're going to see, where's our object, birthday? Well, we can grab any, like, for example, this one. Package is false, and this right here is the JSON representation we mentioned before. So we can see it has a property number, and it has to be a minimum 0. So what we'll grab that, use TypeScript API, and then construct the struct of this. And we see we've generated the schemas in here. We go generate it, and then this square struct, right? So as we mentioned before, the same format, and it'll be similar for all of them. But the important part is this one. So it's asserting that it's greater or equal than 0. And if it fails, it'll throw this custom error. So, well, how would someone go about consuming this? So here we got squares. Here we got our contract here. So it's square contract. And you can see it is importing the struct. And we can use it as a type, define it, and then just instantiate it like here. So this that will be square, and we've got two functions. One to update the number itself from the struct, or either pass a new struct. And if we go to our test, we can go join test, and while that loads, we can see here that it instantiates a new method, a new square struct, sorry, and it'll pass through. And if we place 0, when we instantiate it, it'll throw. And that's exactly what we want. Yeah. Any questions up to now? We're good? Perfect.
Makes sense.
So lastly, from here, I want to show you the compact. So if you want to, we go to schemas, we see here, we got a object with 1, 2, 3, 4, 5, 6, 7, 8, 9 fields, if you will. So we're going to have to compact it. Otherwise, we're going to hit an error on the structs. We're going to get sock, generate it, and we're going to go packed entity, and we're going to tell it from that file, just work on this object. Perfect. We go into the generator here, compact. And experimental is a bit wild, but if we go on to array, for example, for A1, we see that it's passing the first field, and then we're passing an offset and the size of that number. And that's how we are able to access that number. And it goes very similar with the set A1. So it's working with offsets and the sides. And so that's basically how we are able to access different parts of the field and either read from it or modify it. And then I want to show you guys the sock. So let's go into the code a little bit. So it has an index where we run the commands and it interprets them. But the cool part is here within the code gen. So first off, yeah, so let's here, for example, get check statement. It'll grab the property name and its type. And if it's a number, for example, then it will create that assert specifically for that number. It can be, you know, either greater than or less than, and it will create a specific assert for it. And if we go to create class, here we see, for example, members. It'll get the constant, the constructor function, the check function, and it'll create from the factory, it will instantiate the struct. And then if we go on to the bottom, here's where we write onto the generate folder, the struct file. And one more thing we can show you guys is here we got another example. So it has a validation, it has a vaccine struct, and it's been imported from here. So COVID vaccine status. And we're able to extend it and add our own functions here. So then we can create it and, you know, call that function. And I think this is pretty cool, since you could, you know, have the COVID vaccine status be generated and then just extend that file from elsewhere. And if you ever want to make a change onto the schema, it'll be reflected upon all the dependent classes. So yeah, that will be it. Thank you, and let's open the floor for some questions, if there are any.
Really well done, especially now seeing kind of what other people have been presenting over the past couple of days. I think that this is a tool that can plug directly in to help other people along with their journey. One of the things that we're going to do afterwards is like we want to have like a direct follow-up around what specific follow-ups can be in terms of getting this used. But I'm just curious around right away, where do you see the kind of like first or like the best use case to be for other developers in their application journey?
So actually we came up with this idea playing around with medical data. So my background is on medical informatics, and the first thing I tried to do with the, with Mina, it's, try to make vaccine passports and such. Yeah. And so I see people trying to model complex data, trying to use this utility. Currently, it's very early stage, and it's hard to get people to use, a library for complex data when, currently, at least for what I've seen, there are very simple applications with not simple applications, but simple data being used. But when, people get more aggressive, if you will, in the things they want to build, I think that's where tools like ZOC will be very important. And to answer the question, I think medical data, correct. I can think of any other place where you would need to structure complex information, or where you need to validate a lot of input. So for example, if you've got an API of some sort, then this will be very useful to describe the data you will need to pass in, and right away you can check that it asserts everything. I think that's where it can be used.
Yeah, interesting. There's also a lot of different, and this is something I'm learning a lot. So this might just come completely this might be completely independent, but there's a lot of talk around converting or building Snarky.js libraries that would be the equivalent of like Circom's machine learning library suite that they have to validate like EZKL for zkML. I'm wondering, like, for Cohort 2, there's I think 3 or 4 different projects related to zkML. all around being able to prove large models, inputs and outputs of large models were, to be able to prove inputs and outputs, but while keeping the weights and the details of the model private across the different parties. And I'm wondering, like, if this can be a kind of like a complement to when those those libraries become available, being able to
that's true.
update these schemas within them. Well, I'm really impressed. I'm really like excited. I think like this definitely falls on the more, I think, like in-depth set of tooling that is going to be available, pending kind of like following up and making sure that we're crossing all of the last bits to make it production ready. But yeah, very, very impressed.
Thank you, guys.
Maybe one last question from me will be, how was your experience like learning SNARKs? Especially, I am curious. What we hear a lot is it's like it's easy to start, but when you get deeper, it's getting like a bit dizzy, like fizzy, and like harder. So I'm curious about your learning curve and experience with getting a prof in SNARKs or like getting this level.
Yeah, well, Ignacio will be better to answer that question as well. But so yeah, please.
Yeah, I can jump in here. Yeah, at first it's really simple, like you think it's like magic, but then when you try to do something more complex, you start hitting some issues, and then the real issue is when you upgrade the SNARKs version, which sometimes breaks everything that you did before, and you are not sure if the problem is the new code you add or it's only the new version. But so far, I think it's been really like not really great, but I've seen like a lot of worse experiences before. And considering that it is a really new ecosystem, this whole zero knowledge proof thing, I think it's really good. The one last bit, the thing that could be improved, I think it's the errors. The errors sometimes are not really helpful to understand what's.
You mean the explanation, right?
Yeah.
It doesn't explain what is there. Yeah.
Sometimes only says, I don't know, Stack Overflow, and you just, I don't know, you add one line, and you don't understand why it's throwing an Stack Overflow if I'm just adding two numbers. But it's mostly the SNARKs version.
Thank you, Ignacio. Thank you.
No worries.